Hello, everyone. Welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry at Florida State University. I'm a photochemist slash photophysicist. I care a lot about what happens to light when it interacts with matter or molecules, where that light energy goes, how fast it goes there, whether it makes and breaks bonds, transfers energy, moves electrons, moves protons. I care about understanding and controlling those processes. But more importantly, joining me today is Dr. Emily Stewart. Emily, if you wouldn't mind introducing yourself.
Hey, I'm Emily Stewart. I'm an assistant professor at FSU, so I've just finished my third year, I guess. I'm a geologist. Specifically, I study metamorphic rocks, so rocks that get changed when they're subjected to really high pressures and temperatures deeper in Earth's crust. We're talking, tens of miles underground. And I'm interested in how those processes make Earth a habitable planet. Like, why has life existed on Earth for billions of years, and what does it have to do with these geologic processes? In particular, how they move elements like carbon in and out of the solid Earth and maintain a habitable climate on our lovely habitable planet.
At least for now, it's habitable. What do you typically teach?
So I've taught physical geology, which is kind of the intro geology class for science majors. And then I teach a class called Igneous and Metamorphic Petrology. Has nothing to do with petroleum. Petro is just the Greek root for rocks. So it's a class about igneous and metamorphic rocks. That's for upper level undergraduates. And then at the graduate level, I teach a thermodynamics class.
Nice. All right. Equally important, what game are we starting with?
That'll be Mario 64.
So this one takes us back. I don't remember the year this one came out.
I think it was
there it is, 96.
Yeah, I think it came out with the system, right?
Yeah, this was the main release. Yeah.
Yeah. So
there's the head.
All right.
All right. So I'm going to jump you. Should we just skip through this? And
sure.
I'll get you. I save stated so we don't have to go through the text box and whatnot.
At the front of we're here to save Princess Peach.
Yeah, exactly. Spoilers. That is the lore behind every Mario game, or most Mario games at least. So how long has it been since you played this one?
I mean, gosh, it might have been 20 years.
20 years.
I mean, I feel like I've probably had a nostalgia run on it more recently than that, but I don't remember exactly. I know this is the first door you can go through.
And so this one you have to collect stars and then eventually get to Bowser.
Right.
So this was the first 3D Mario, if I'm remembering correctly.
Yeah. Yeah, and so this system, 64, was like the first really 3D. Well, I mean, so I never had an SNES. Mm-hmm. We went straight from NES to N64 when I was a kid, so it felt like a pretty big leap.
Yeah. Well, the original NES had a few games that tried. There was one called 3D World Runner, and it actually came with 3D goggles, but it didn't work particularly well. But they definitely tried. We could bust that one out later if you want to give it
I also
try.
Remember Snake Rattle and Roll had this like weird kind of perspective.
Yeah. They did the best they could with those 8-bits. What's kind of fun is this game is surprisingly topical right now, or at least with the retro gaming community. I don't know if you heard about this.
No.
But a guy just broke this,
ground pound.
This 30-year challenge, and the challenge was to beat beat this game without pressing the jump button.
Oh, wow.
Yeah, exactly. So, how does one do that? And the answer is it took him 86 hours to do this and a whole lot of glitches.
Yeah.
It's anyone that's interested, Bismuth has this really nice breakdown, but basically there are certain times where you need to jump, but he can't because that's the challenge. And so he does these glitches with pulleys and all sorts of objects that make him levitate in the air and climb up the screen, and so that happened last week actually.
Oh my gosh. Okay.
Great.
Wow. I'm just getting coins here so that I can go back and try to remember how to ground pound and beat the chain chomp. But I'm pretty rusty.
No worries. I promise you no one comes to the stream for the gameplay. The fact that you're moving around and not standing in a corner is a good start.
Yeah, all right.
This will quickly, nostalgia will take over very quickly. But yeah, it seems like you're in the groove. You at least know what buttons do what.
Yeah,
we'll give you the
for
ground
the
pound
most
here.
part. I gotta get on the post. See.
Oh, there's the pound.
That's the pound, but I have to do it on this post. Maybe I should just try the one where you get to the top of the mountain. Maybe that's a better warm-up.
No worries. Whatever you're having fun doing.
Woo!
But yeah, we'll settle in. We'll open up to questions pretty soon. But the one we always like to start with, and this is because our paths are always so convoluted. Chances are 6-year-old Emily did not envision herself as a geology professor playing Mario 64 on a Wednesday night during the summer. So there was a journey that took you here, and that journey had many turns and many forks in the road. What was that journey, and do you remember specific instances where it was like, I love the sciences, geology speaks to me, particularly the sequestering of carbon and release of elements? Like, what were those milestones?
Yeah, so I mean, I think when I was a little kid, science was something that appealed to me a lot. You know, I think like a lot of little kids, I thought I was going to be a marine biologist, which is not how it worked out. But
Wait, did you live on the coast?
no, I grew up in North Alabama.
Okay.
So that was coastal, you know, 80 million years ago. So does that count?
It's close enough. I'm sure 6-year-old you was like, close enough.
But I, in high school, got really interested in music. So I was still, I think my college entrance essay, I said I was gonna triple major in like physics, philosophy, and music, which is kind of a lot. And is not what ended up happening. But so I went to undergrad. My first year of undergrad, I was in the music school. So pretty different trajectory. But then my friend and I took this kind of epic road trip the summer after my freshman year of college. I don't really remember how this works. I think I'm supposed to pick him up. But we went on this road trip where we drove from Alabama to Alaska, which is a long way.
Yeah.
How does this... I know I'm supposed to pick him up, but I don't remember what button it is.
Anyone in chat knows we are okay with backseat gaming.
Oh, that it must... Maybe it's that. Maybe it's B.
You got to kick him.
Something like that. I think it maybe becomes a pickup if I'm in the right spot. Yeah, there we go. All right.
All right. Road trip to Alaska.
Right. So we drove to Alaska, lived in tents for a couple of months.
Wow.
And I was working at a grocery store to pay the bills, but my friend was working for like this grizzly bear viewing company that would fly people out to see grizzly bears. But anyway, we were living outside in Alaska, really just getting to go like hiking every day and looking at glaciers and volcanoes and sitting by a campfire every night. And the idea of going back to music school and sitting in a practice room with no windows all day, every day, was too horrible to imagine. So I switched to a geology major from the public library in Homer, Alaska. I had never taken a geology class, so it's actually a miracle.
Oh no.
I made progress, so. I'd never taken a geology class. I think the last time I had studied geology was like 2nd or 3rd grade.
Geology loosely defined.
Right, like what's a rock? But I knew I wanted to have a job where I got to go outside sometimes. So that was my motivation, really, to switch to the major. And I looked on I did my undergrad at Indiana University. I looked on their website and I saw photos of their field camp. So a lot of geology programs have like a capstone field course. So for their course, it's like 6 weeks in Montana. Oh no, bad start. Working in the field in the Tobacco Root Mountains in Montana, and I just saw the photos of the field work and thought it looked fun.
But at that intersection, you could have gone with marine biology. Right?
I think, I looked on the biology website at IU and I didn't really see, right, I think like the Midwest is maybe not the
Good point.
of marine biology. I think, I had also met some geologists in Alaska who, talked about their degree, and it occurred to me that it was like an option.
Yeah.
But yeah, so I just started taking classes, and
So you drove back from Alaska.
yeah, I took like intro geology, which actually was not all that exciting to me. But then I also took a mineralogy class that same semester that I shouldn't have been allowed into. I didn't have any of the prereqs for it, but somehow the computer system didn't catch me, and
They let the music major sneak in.
and I was allowed to take the class, which is really lucky because it was like a huge influence on me. I loved it.
I'm curious, the intro to geology, have you taught that here at FSU?
Yeah, I taught it last fall.
Is it
Yeah.
is it the same stuff you hated when you were an undergrad, or
It's similar, yeah. But I flatter myself that my classes is more exciting, but
Yeah.
I don't know.
That's possible. Any students in the audience?
Yeah.
All right, so you took the mineralogy class, you fell in love with it, and that was the rest of your undergrad. Did you end up doing physics as well? Or
No, I took like a few semesters of physics. I do remember, this is just to all you physicists in the audience, I remember the physics students in my physics 3 class like saw that there was a geology major on the roll, and they were like, "Huh, what's the geology major doing?" And it was like relativity and
Yeah.
like special relativity and some quantum stuff. And they were like dunking on me for being a geology major.
Yeah.
But I set the curve, so I was.
I was gonna say, we're all inclusive here. No pretensions.
No, I did end up doing a math minor, which has served me well. It's definitely been useful.
Oh, that's fun. Airbus 35900 or 350-900. I'm jealous you can answer questions while playing video games.
Sort of.
It is challenging. I think this one's a good one, open world, because you have a lot of space to work with,
Yeah,
trying to focus.
I can always just run away if things get too hot.
Yeah. Yeah, welcome to stream. If you guys aren't following, click the follow button. It helps with our visibility. It gets our numbers up, and also you get notifications about future streams. We only stream every other Wednesday night, so you don't get a lot of notifications, but when you do, when we go live, you will know. Seconder, thank you for the follow.
Oh, hey, Alex.
Oh, that's one you.
I think so.
That's awesome. Welcome to stream. Thank you for following. You got a whole bunch of standard internet units. Airbus, thank you for joining us as well. Thank you for the follow. Yeah, we're recounting the story of Emily becoming a geologist. We had you graduated with your geology major and you decided I need to go to grad school.
Yeah, I mean, so I did get to do some. I'm so close to beating this, but I'm gonna die if I get hit again. I did some undergrad research, and that was in metamorphic geology. So for that, I got to go kind of to New England and work on some old rocks in Connecticut that are associated with all the mountain building events that created the Appalachian Mountains.
Was that like an RU thing, or?
It was like very informal. Basically, my undergrad professor, Bob Winch, just kind of invited me to
Come get in my truck.
yeah, basically. Yeah, like, come pick up some rocks with us.
That's amazing.
And so, yeah, we ended up, I got to go to like a couple conferences, like regional conferences. But so that was really, working with him was what got me interested in metamorphic rocks.
That's awesome.
So then when I applied to grad schools, I was looking specifically at other people who do, I'm so close.
Wow. Yeah, the depth perception on this is hard.
All right, there we go. Yeah, I was looking for other people that do metamorphic stuff.
And so you found, I mean, how many people is that? How big is that community?
Not every geology program. Wow, I thought I could just jump and hit that. Maybe I need to triple jump.
So this is the odd. So I never played this game, actually. I played Nintendo and Super Nintendo versions of Mario, but I never played the Super Mario 64. But now I play Mario Maker on the Switch? Are you familiar with that, where people can make their own Mario levels?
I've heard of it. I haven't played it though.
And so that was my first encounter with things like the triple jumps, the wall jumps, the ground pounds.
Yeah.
And those are in like New Super Mario Brothers and so on. It's fun to see the origin here.
Yeah. I think there's a slide I can get into now. Maybe. Yeah, 1 star. So you can only go into these rooms after you've unlocked so much.
Unless you glitch through the wall, apparently.
Right. Yeah, I've seen there's like an infinite staircase that you can glitch through if you...
Emily, we asked this of all of our guests. What do you think the speedrun record in this game is? The fastest someone has beaten Mario 64?
Like any percent?
Any percent.
I've seen people do it in, I think, a few minutes. I don't know exactly. Because you have to like slide up the infinite stairs. Like there's a bunch of glitches, right?
Yeah.
But I would say 4 minutes, 5 minutes, something like
The
that.
answer is 6 minutes and 16 seconds.
All right, I
So
wasn't
pretty
that
close.
far off.
Yeah. I mean, you've seen enough of the you appreciate the glitches you can do. Who needs stars? Just go to Bowser.
Yeah.
All right, so you went to grad school. You found somebody. I mean, how'd you pick between different schools? What was your final? I mean, you're looking in this particular subset of research, and there's a dozen people that are really good at that.
Yeah, so I applied to like maybe 5 or so programs, and then I think the visits were really influential.
Oh, yeah.
The twist ending is that I had kind of narrowed it down to 2 programs, and I ended up going to one to do a PhD, and then that program unfortunately went through some difficulties, and my advisor left that program, so I left that program with a master's and ended up going to my second choice for my new first choice PhD, which like worked out super well actually. I think I'm really...
Oh, so they didn't move, they just bailed on academia.
Well,
entirely?
he moved from Boston University to Boston College, which was very confusing for everybody involved. But
when you need to start life over, move across town.
at the time, Boston College didn't have a PhD program in earth science. It was just a master's, so
I see.
it wasn't really feasible to follow him there. And I mean, the other part of it was that program, and part of the reason I picked that program is because it was very lab intensive. So the research was doing geochronology, right? Figuring out how old stuff is. So we were measuring samarium and neodymium isotopes in the mineral garnet to kind of use the radioactive decay to calibrate how old those minerals were.
Yeah.
Which is super cool work, and I'm super glad that other people are willing to do it, but it's really painstaking.
Yeah, that's analytical chemistry, right?
Yeah, exactly. So it's a lot of column chemistry,
Yep.
and then TIMS analysis on like nanograms of material. So turns out one thing I learned in my master's program, is that I'm not a talented lab chemist. The number of times I would be working on a sample and it'd been like 2 weeks of really concerted effort, and then just bump it and it's gone forever.
No.
That was always devastating.
Some people like lab work, some like sleeping in tents. You were the latter.
Yeah.
We learned that very quickly.
So the work that I did in my PhD was more, descriptive and computational stuff, less lab intensive in terms of generating difficult to generate measurements. That's no longer my specialty. And now I have grad students to do measurements for
Isn't
me.
that amazing?
Yeah. And some of them are actually really talented lab people, so I'm grateful for them.
Well, you get the diversity of talent. You have one person that really loves doing those measurements, right? And then you have another one that wants to be in the field. And no, that's awesome. So after grad school, it was a postdoc?
Yes. It was a 1 year, 11-month pandemic postdoc.
Oh.
So I started that postdoc in August or September of 2020.
Oh, God.
luckily, I had already interviewed for faculty jobs, actually.
Oh, wow. Okay.
As a graduate student. So I already had this position at FSU lined up. And they let me defer for a year to do a postdoc.
That's awesome.
And it worked out really well because I wasn't like one of those pandemic postdocs trying to get a job in an impossible market, like trying to be productive. Nightmare scenario. So I was actually able to kind of enjoy my work a little bit more, but it was definitely, I definitely think I like missed out on some postdoc experience that I would have otherwise had.
Yeah. Oh, that makes sense. I mean, but then you already had a job lined up. You were starting to create a vision of what you wanted to do independently.
Yeah.
So pros and cons, I guess.
Yeah, I think it definitely worked out. And the thing I would always tell people, like, oh, I felt like I spent the whole postdoc alone in a basement lab, not talking to anybody, or like, having any social experiences. I feel like I didn't really get the full Caltech experience. But then people say, no, that basically is the Caltech experience. So maybe I didn't miss anything.
I mean, postdoc in general is a much lonelier experience.
Yeah.
Because grad school, you came in with a cohort of students.
Right.
And as a postdoc, you're like, if you're lucky, I mean, I was in a weird lab that had like 8 postdocs. That's all they took. But I mean, even then, that's still a very different experience. Not only that, like postdocs are at very different points in life, right? Some have kids, some are older. So it's a unique experience. But one I wouldn't trade for anything. So mine also wasn't during COVID. So
right.
All right, then so deciding like carving out your individual research as a PI. I mean, how in my field typically we try to differentiate, try to define ourselves. How different do you have to be?
I think I'm one of like a handful of people that do what I do, and I think I'm like pretty lucky to have stumbled onto this discipline. Metamorphic geology has, I would say, kind of a bad reputation in among geology subfields. Even when I was interviewing for jobs, sometimes people would say to me during the interview, like, oh, I thought metamorphic petrology was a dead field until, I thought no one was doing anything interesting there. Which is not true, but that's kind of the reputation that it has. But I was pretty fortunate in that my advisor and a number of other people in my PhD department were interested in the global carbon cycle and how it relates to metamorphic geology. And it was kind of a lucky confluence of these different areas.
I mean, so how much of that is just like dogmatic based on, so if you go into geology, you're like, rocks are rocks, and I understand rocks, and you come in with metamorphic, which means it's changing.
Right.
And they're changing form, changing phase. Like, is that just people are uncomfortable with that idea and it's just hard to study, or what's the...
Yeah, I mean, metamorphic rocks compared to other rocks are kind of a mess because a metamorphic rock used to be a different rock. So when you're looking at a metamorphic rock, you have to contend with its whole history before it became a metamorphic rock. And then it gets messed up by stuff. So there's kind of like layers and layers of information that you have to sort through that make it, I would argue, a little bit more complicated than some other, I mean, I think everyone thinks their own discipline is the most complicated. But I think, so metamorphic rocks, they have this like more prolonged history just because they all had to have been another kind of rock first.
Yeah.
And then the other aspect of metamorphic rocks is that they're cold enough that like they don't always reach kind of chemical thermodynamic equilibrium.
Oh, that's interesting.
So in igneous rocks, you can often assume equilibrium. They're like hot enough. But
so when you say hot and cold, that's a temporal thing, or is that...
so I would say, so the coldest igneous rocks, the coldest common igneous rocks are going to be somewhere around 700 degrees Celsius.
Okay, it is actual temperature, all right.
Yeah, and then, magmas are often over 1,000 degrees, 1,200, 1,400. Whereas metamorphic rocks, you're looking at 300, 400, 500, 600 degrees Celsius, like sub-melting temperatures. So
it's just strictly temperature. Do you care about pressure when describing or defining that boundary?
You definitely do, but in terms of like the kinetics, it's more sensitive to temperature, right? There's just like the Arrhenius type temperature stuff. So pressure and temperature are both really important variables when we're thinking about metamorphism, but it's the colder, relatively speaking, colder temperatures that mean that metamorphic rocks are not always, they're kinetically limited, so they don't always have the time necessary to achieve equilibrium. So then when you're looking at them, it's harder to figure out kind of what conditions did this rock format, because it's not perfectly recording those conditions.
Nice. Got it. GG's.
Hey!
Count that. That's beautiful. And so that's intriguing, because then you presumably have this rock that has amalgamation of a bunch of different phases and a bunch of different transitions adjacent to each other.
Yes.
And you try to tell a story based on that.
Yeah, exactly. So one of the metaphors that I've heard is this idea of like a palimpsest. So this is like old-timey, like medieval monks. Paper was a much scarcer resource, so you would sometimes write on a piece of paper and then you would write over it, maybe scrape it off a little bit and try to write over it, but you're not completely erasing that prior history. So there's like layers of writing on a single piece of paper.
Or 6 layers of paintings. And,
right. Yeah, exactly. Yeah. So I like to think of metamorphic rocks in a similar way, like they're recording multiple layers that have been partially obliterated, but you're trying to see as much as you can in each stage.
I mean, that's intriguing, because each composition you could radioactively date, right? And then new composition, it starts a new dating timeline. Like, that sounds like a fun way to tell a story.
Yeah.
All right, Lori had the question. Sorry I'm late. What's the drink of choice? Lori, welcome back. Always a pleasure to have you. Emily, what is our drink of choice tonight?
Oh, we're drinking the Sea Quench Ale Session
Oh, no,
Sour.
green screen. There you go.
Oh.
Sorry about that.
Yeah. Wow, yikes. Yeah. It's a beautiful green can.
Put it on the, yeah, sorry. There you can see the Sea Quench Ale. Any particular reason behind this one? This is just...
I just like it. I feel like this was the one in grad school that if you ever brought Sea Quench to a party, it would be gone immediately. Yeah. I'm really glad sours are becoming more of a thing. I
actually have a sour from Proof in the fridge if you want to try that next.
Yeah, that would be awesome.
Yeah, I'll grab that. Yeah, I completely missed that this is sour until I drank it. Oh. I noticed immediately.
Yeah, hard to miss.
Yeah, Lori, hopefully you have a drink in hand. Cheers. Thank you for joining us on Wednesday Night for Gaming. If anyone has questions, my guest today is Dr. Emily Stewart. She is a geologist. She's an expert in metamorphic rocks and trying to map their formation and change over time, as well as how they release things like CO2 and sulfur, and how the transformations dictate habitability on the planet Earth. What was the line I had on? I saw this on your webpage. Global carbon cycle in deep time.
Yeah.
That just sounds like a sexy topic. Yeah. Maybe the nerd in me is coming out.
I think deep time is always a fun phrase to throw out.
Yeah. Oh man.
Some ASCII art.
Yeah, I have not seen ASCII art. Well, now we're getting spammed with it.
I see.
I'll take care of that. All right, let's time them out.
I do like birds.
We'll take that. All right, sorry, I'm slow on my moderation here. Let's see. There's another one. There's another one. All right, we got it. 600 seconds. We'll see if they come back.
All right.
Misadventures, welcome back to the stream. But yeah, thank you for joining us. If you guys have any questions, we should do a prediction. Do you want to pop up one of these? Which one are you excited about?
Sure. I'll start at the top, I guess.
All right. All right, ladies and gentlemen, if you're not following us, click the follow button. You'll get a bunch of standard internet units where you get to gamble on a prediction. On Twitch streams, predictions are typically video game related. Not on this stream. We have our guest. We forced them to write several prediction questions. So I'm going to pop a question up on the screen, and then you guys are going to pick one of the answers. And you're going to have standard internet units, which is our imaginary internet points for this channel. And you can gamble how confident you are in each of the answers. You can do this by whatever knowledge you have or what you know about Emily. Note that you are on Ask a Scientist Gaming Honor Policy. You can't GPT chat it or Google search it. Let's just do it based on the knowledge you have of these questions. So at the top of your chat, you can click the predict button right now. And the question is, what's the age of plate tectonic theory? At least, I guess, any qualifiers on that? Just the
theory of plate tectonics. When did that show up?
Was it before 1950 or after 1950? Spoilers, it is not exactly 1950. So pre or post 1950? Yeah, misadventures. ASCII spam is a new one. I don't think I've seen that one on stream. But yeah, you guys click the predict button, make your predictions right now. And if you're not following, click the follow button to your standard internet units. They are useless outside of the stream, but on the stream, you can request a factoid with it. You can make us take a drink. You can unlock some of our emotes, including Deity Carl Sagan, and we have some OSHA emotes. So feel free to unlock and have fun with those. But yeah, the question is plate tectonic theory. Is it pre-1950s or post-1950s? Which I always love these because outside of my field, I don't have a good concept of timeline generally. So
right, yeah.
I'm excited.
I don't remember what else to do in this snow land, so I'm gonna keep moving.
Yeah, if anyone wants to backseat game, Emily's not going to take it personally. If you have comments or suggestions on where she should go, we may or may not follow your instructions, but we appreciate the advice. So, but yeah, click the predict button. Plate tectonic theory. Was it pre-1950 or post-1950? And this is the initial proposal, or this is like when it was accepted?
I would say the like when it was first like fully framed. Yeah. So like I'll give maybe this is too much of a spoiler, but something like continental drift, we would say is different. That's like not really explanatory. It's just kind of like an idea. Things are moving, but we don't know how or why. So for plate tectonics, I mean something a little bit more like mechanistic.
All right, so pre-1950, post-1950, you have 5 seconds, and it's done. Emily, what's the answer?
Post 1950.
Which is crazy.
How did they do?
That is 75 years ago.
Yeah. Yeah, it's really shocking how recent this like big revolution in geology is.
So do you have any textbooks in your office that don't have plate tectonics?
Oh yeah. I mean, even my parents probably, I guess, I mean, they would have encountered it if they had taken geology in college, but they would not have learned about it in school. You know?
Oh, that's a good point. It didn't even propagate through. I mean, it takes 20 years
right.
to go from
and it was much, I think, slower to be accepted in like Soviet countries. So they're even a few decades behind. But the like observations that really kind of sealed plate tectonics were made in the late 50s and early 60s. And it was probably broadly accepted in the 60s. Oh, I fell.
Misadventures. Thanks a lot, Stalin. Oh, don't even get started on the impact on biology and evolution. Oh, man.
But it's actually kind of terrifying to think about because I look at these geology papers from, the first half of the 20th century, and those people really thought they knew what was happening. They had this like kind of complex geosyncline theory to try to explain some of their observations. If you think about a big horizontal fault that's carrying like a big sheet of rock, I'm racing Cooper the Quick. I'm pretty sure I lost already.
Yeah, there's a suggestion here from Seconder. Use the boost to get through.
That's, I think that's a Star Fox reference.
Oh, nice. That's amazing if it is.
Yeah, your father helped me like that too. That's also a Star Fox reference. I lost to Koopa. But they would try to explain like a big horizontal fault with like a kilometer of horizontal movement on it, but there was no real way to generate horizontal forces without plate tectonic theory. So they would say things like there must have been a mountain range here that's gone now, but was like big enough that these rocks slid down this enormous mountain range and gained enough momentum to slide a kilometer horizontally across the Earth. Because that's the only explanation for it.
That's such a mind-blowing position to be in, because you're just like, that mountain disappeared and somehow that happened. But I know what it's made out of. Like, what a discomforting time to be a geologist.
Yeah, I can't imagine, like... But then, you know, presumably we're all doing something equally as insane. We just don't know what it is.
Yeah, does that give you an existential crisis?
Oh, always,
like, wake
yeah.
up in the middle of the night sweating?
Yeah. Yeah, definitely.
That's awesome and amazingly self-reflective. So, congratulations, anyone that picked post 1950. It turns out you guys bet a whole bunch on that, so you didn't win much, but you did get pride out of that answer correct. So, post 1950s, only within the last 70 or so years have we known plate tectonics exists, which is again crazy because you can't explain earthquakes without it, right? Like,
Yeah.
wow. All right, Seconder. How much do you actually use calculus as a geologist?
Oh, interesting question. I do actually use calculus fairly regularly, but honestly, I mostly have a computer do it for me. So in a lot of the calculations I do are basically like chemistry, thermodynamics type questions that are predicting how the stabilities of minerals change with pressure and temperature. And so a lot of those equations are set up as integrals from some reference pressure to the actual pressure of interest. So I'm doing that kind of thing a lot, but often I'm having a computer kind of actually do, oh my gosh.
I mean, in your defense, though, like most of us that use calculus don't derive,
Right.
calculus relationships. We use it as a tool for integration, for differentiation, so on and so forth.
And I actually did do a little bit of like pencil and paper calculus a couple months ago because I was trying to like justify sitting something as like a natural log. So I had to do like and it was not advanced stuff, but
yeah. No, I've caught myself doing that. I don't know if you remember back to general chemistry, but doing like ice tables and like the initial change equilibrium calculating. I actually did that for a pH calculation for a photoassay, which is the first time I've published over 100 papers, been cited 8,000 times, and I did an ice table for the first time about 6 months ago. Nice. So yeah, it's going to be useful someday, we promise.
It'll come up.
But then I like look it up anyway. If I didn't teach it, I'd find it on the internet and they'd solve it for me. Cuddle puppy. Make her do the speed run where you don't press the jump button.
I don't think he want to be here for that.
Man, it's only 86 hours. That is the current speed run record for not pressing the A button. But yeah, if you guys haven't seen, I'll find it. Because he breaks down like the number of glitches you have to do through walls, and it's like don't press A or something. Oh yeah, blindfolded.
I
That's
really
another
thought
study.
I got him.
Happy category. Give us more time to talk about science. All right. Lori has... Oh, wait. We have a follow-up question on the calculus. Who's your favorite calculus teacher?
I don't know if this is my friend fishing for compliments. I mean, he was a calculus. I mean, did you help me with calculus? I don't know. I don't...
All right. Sorry, make a video.
I don't remember his name, but whoever taught Calc 3, I took Calc 1 and 2 in high school, which was also good, but my Calc 3 teacher was awesome. Plus, Calc 3 is just, like, objectively the most fun, I think.
It's fair. All right. So there's a link to the Bismuth video if you guys want to check it out. Check it out after the stream's done. But yeah, that's beating Super Mario 64. It's called the A button challenge, where you don't press the A button. It started out as a curiosity, and then somebody committed to actually beating it, and it took 86 hours, which is absolutely insane. So yeah, check it out after the stream. Lori's redeemed request a factoid. Emily, do you have a knowledge bomb you'd like to drop on the audience?
Sure. So this one I tell my students a lot. The rate at which tectonic plates move is about the same rate at which your fingernails grow. So every time you trim your fingernails, we're that much further away from Europe. This is adding to your transatlantic flight.
Yeah, just a little bit. That is amazing, the scale of that. Is it just me or all these bosses similar?
Yeah.
Get behind them, perform something. In 50 million years, we're going to be a supercontinent, though?
Yeah, there will likely be another supercontinent.
We're just going to mash into each other on the opposite side. And
It remains debated which ocean basin is going to close. Some people think the Pacific will close. Some people think the Atlantic will close. We don't know. And depending on which way it closes, people give it different names. I think like Amasia is one of them. And
that's fun.
I don't remember exactly, but yeah. So most people, if you're familiar with a supercontinent, you're familiar with Pangea, which was the last supercontinent about 250 to 200 million years ago. Yeah. But there were at least 2 or 3 supercontinents before that. So Pangea, if you go back in time, Pangea breaks apart and becomes, oh, I need 8. Close. Pangea breaks apart and goes back together, and we call it Rodinia. And then that breaks apart and goes back together. And is that Nuna, or is that... anyway, there's a bunch of these supercontinents.
Yeah. Anyone in chat want to fact check Emily in real time, feel free.
I'm like, I just put this in a figure. I'm trying to like see it. There's like Columbia / Kenorland maybe comes in between those, and then Nuna.
Misadventures in Astro said, sounds right. let's trust the astrophysicist.
But yeah, we'll collide eventually. I mean, that I think is one of the weird things about studying geology, is that you do get used to thinking on these very long timescales. And you start to think of things as being short term that are not really. So, you know,
scale is completely off.
My first published paper was a geochronology paper, and I got the error bars down on an age to like plus or minus 1.9 million years. And like that was a master's degree, and that was a published paper. It was like, hey, we know this age within about 2 million years. And that was like a huge improvement over what had been known. So then I think about things like magnetic reversals that typically happen on like 100,000 year timescales. And I think, oh, it's going to be so cool when the poles reverse and I get to see it. And then I remember that that probably won't happen in my lifetime.
2 million years is like 50,000 generations or something. Like that's evolutionary time. That's intense.
It's a long time. All right, this is where I fell off last time I raced.
Does it, I mean, thinking of those scales, does it haunt you at all that you'll never get to see any of this happen, but you can make a guess as to what will?
Yeah, it's definitely kind of an interesting challenge to like imagine these processes. You know, I think about it as like a flea living on a cat, and that flea gets to like, over the course of that flea's entire life, the cat will blink once. And like, how much can the flea learn about how cats work, you know?
Yeah.
All right, I think I beat
Seconder, I was 100% fishing for compliments. Good luck simultaneously stomping on Goombas and saying isotopes. I have to go out a toddler to bed. Assuming us take a toddler to bed. That's awesome. If a movie was made about Dr. Stewart, I think Leah Thompson should play her, as she's been told that that's her doppelganger.
Have I been told that?
Has she been told
Oh,
that? Yep.
I don't know who that is.
Leah Thompson, mom from Back to the Future.
Oh,
Or
okay.
in Howard the Duck, the love interest of the duck. Look up a picture of Leah Thompson.
I don't know who Shisty448 is, but they're definitely reading my papers.
So that's Leah Thompson.
Okay, I'll take it.
Thank you, Lori. We'll count it as a compliment. Although
You're allowed to stay on the stream.
Yeah, we won't time you out. All right. So Shicey's going technical on this. Did convection currents come first, or ridge push/slab pull? So can you define those terms
Sure.
for the layman audience?
So tectonic plates, right, are moving around the surface of the Earth. And there are two kind of main forces that could be pushing these plates around. One is slab pull. So this is when part of a tectonic plate, like oceanic crust, becomes... I have to talk with my hands. Hard to game and talk with my hands.
No worries.
The plate becomes dense enough, or that's kind of the classic view, that it becomes cold and dense enough that it has negative buoyancy and this plate starts to sink down into the mantle. And it's that density kind of pulling the plate along behind it that's driving plate tectonics. So that would be slab pull. Whereas ridge push, this is at the other end of the plate at like a mid-ocean ridge where the plates are pulling apart and new crust is being created at these mid-ocean ridges. At those points, there's this idea that maybe there are these hot mantle plumes that are kind of rising and pushing the plates apart at those points. So you have kind of mantle convection driving the mantle to rise and kind of spread out and push the plates apart. So these are the two kind of competing ways to drive plate tectonics. Oh, I've done this one. So then the question is, which came first?
Did convection currents come first, or ridge push slash slab pull?
I think like...
The concurrent processes?
Right, they're both happening. And so then the question of like which one is mostly driving plate tectonics today, there's like a kind of classic paper by Forsyth and Uyeda from the 70s that pretty convincingly shows that slab pull, I believe, is what's really keeping plate tectonics going. But we have evidence that early on in Earth's history, there was what we would call like more vertical tectonics, which would be, you can think of these like plumes coming up and kind of pushing things around, but they're not like sinking deep into the mantle the way plates do today. And at a certain point, that kind of transitions to a more slab pull dominated tectonic. So I think the going interpretation would be that this convection plus kind of push would have been the initial process. And we see something similar maybe happening on Venus. Yeah, I shouldn't have tried a water level. I think. On Venus today, there are these structures called coronae that are these kind of circular features. We thought they were like impact craters, but they're actually not. They're some kind of like mountain ranges or tectonic features on Venus that are in these ring patterns. And the interpretation of those is that they have like some plume coming up in the middle, pushing material up, and then at the edges you have some kind of pull. I'm leaving this level. I can't, I think I can't get out when I'm underwater because I could, in theory, die. So anyway, Venus is a planet where it seems that there is active, like, convection and plume activity happening in the absence of significant ridge or slab pull. And so I think that is a potentially kind of a good analog for the earlier Earth, maybe.
I mean, to follow up on that, so this is based on photographs of Venus, or this is rock samples, or how do we get that information?
So mostly, yeah, photographs, like satellite radar kind of remote sensing techniques.
So there are astrogeologists.
Oh, yeah.
Looking at these photos.
For sure. And then we do have some chemical measurements from the surface of Venus. There were a couple of landers that the Soviets sent in the 80s, Venera and Vega, I think. And the surface of Venus is hundreds of degrees Celsius, and the atmosphere is super sulfur rich and just really nasty. So these rovers did not last long. They lasted like minutes.
Jeez,
but they were able, but they were able to make some measurements before they were corroded. And so we do have some measurements of the rock chemistry from the surface of Venus from these landers from the 80s. But NASA does have a plan to send a mission back to Venus sometime. But those are the only surface measurements we currently have. I mean, I guess we have some atmospheric measurements too, but in terms of like rocks, it's just those Soviet landers.
I mean, atmospheric, we can do a lot of stuff spectroscopically.
Right.
We can measure that remotely, but like when measuring rocks, you gotta have them.
Right.
Which is interesting. So Ecstatica had a question about, I don't know if this has been discussed, but how much do we know about Venus soil and the surface, which is a follow-up. Misadventures a decent amount, mostly thanks to the Soviets, which we were shitting on them earlier. But,
but yeah, in terms of Venus landers.
Yeah.
Yeah, so in terms of surface measurements, we kind of just have these few from these Venus landers, but there are people that are doing kind of similar calculations to what I do, like thermodynamic predictions of what would happen to rocks in an atmosphere like Venus's atmosphere. And so we can kind of predict what weathering reactions might be like on the surface of Venus. And then there are people that are actually doing experimental petrology or experimental geology, where they're actually taking rocks and like putting them in contact with weird Venus type gases and seeing what happens to them.
That's fun.
To try to learn about those weathering reactions.
Just weird reaction conditions.
Yeah, exactly.
Are you familiar with Susan LaTurner in the chemistry department?
No, I don't know.
So she does crystal growth, but she does it in molten metal flux.
Ooh.
So she uses like gallium and metals like tin and stuff and makes a solvent out of metal materials, eutectics, to grow crystals.
Okay.
And it's just a really exotic, weird condition.
Oh, that's really cool.
Yeah,
I
isn't
should
that
look
fun?
into that. I mean, so like half of my igneous and metamorphic class is learning about like eutectic and paratectic phase diagrams and like melting stuff like that. But it would be cool to see like non-geology applications.
I mean, it's just fun because those unique conditions, you get such weird reactivities, which is analogous to what happens when there's a sulfur atmosphere,
Right.
which is very different than oxygen rich.
Right.
Yeah. Oxidizing versus reducing, and all sorts of weird oxidation states. And, yeah. Ecstatic. Everyone loses their minds about Mars, but I find Venus and what's under the surface in the acid atmosphere fascinating.
Yeah,
I agree.
I'm pretty into Venus right now. I mean, Mars is, for many reasons, just a lot easier to study. So I think that's one of the reasons that it's been such a focus lately, just because we can send rovers there and they don't dissolve immediately. And because the atmosphere is almost non-existent on Mars, we can make really good detailed measurements of the surface remotely as well. And, you know, there's still reason to believe that there could be life as we know it on Mars, maybe. Some little bacteria type things hiding in the dirt. Whereas Venus would not be habitable to life as we know it. So I'll make excuses for our Martian obsession.
That's fair. I mean, and Mars is more similar in size, right? So, like, so something that's interesting about your domain of research, like the thermodynamics and everything, that's driven by, you know, rates of reactions and getting thermodynamic equilibrium. But at some point, gravity plays a role, especially with like tectonic motion and plates and stuff. Do you have to account for that in what you do, or do you care, and would that be different on Venus?
I mean, we essentially account for it in my field just as pressure.
Okay.
And we make the general assumption that pressure is lithostatic, meaning just that like the pressure that a rock experiences is almost exclusively a function of just how deep it is in the earth. So, right, whatever the length of the column of rock above it is, that's the pressure that you're dealing with. There's recently been kind of more work suggesting that there may be deviations from that pattern, that there may be special circumstances, or perhaps not that special circumstances, that allow rocks to experience pressures in excess of just the depth effect. But that's like a very controversial area in my field right now. Oh.
That's kind of fun. The high pressure chemistry is a really hot area right now.
Oh, really?
Like if you put stuff under gigapascals of pressure, like how does it behave differently?
Yeah.
And my favorite of that, I think it's ruby. You can tell the pressure on a ruby based on its emission wavelength. And the more pressure, that's what they use as their reference. So they take diamond anvils, press them together, and they have a ruby sample in there. And they measure the wavelength, which tells them the pressure. And then they measure properties of whatever's adjacent to it. Misadventures, correction, Mars is smaller than Earth.
Yeah.
Venus is much closer to Earth. That's
In
fair, my
size.
bad. What will really blow your mind, there's a point in the solar system where Venus might have been really habitable, but Earth frozen.
Yeah, so there's this idea commonly called the faint young sun problem, where the solar luminosity or the luminosity of stars in general, I guess, tends to increase over the course of this stage in their lifetime. I'm not an astrophysicist, so I won't pretend to know more about it than that, but we have every reason to believe that the sun was not as bright today as it was not as bright early in Earth's history as it used to be. Maybe something like 80% of its current brightness. So then all of our heat and light, in particular heat, should have been a lot less. And with the current atmosphere that Earth has, Earth would have been frozen for a big chunk of Earth history. And yet we have evidence for liquid water on Earth going back billions of years, which suggests that the Earth was not frozen despite a much dimmer sun at that point in time.
I mean, so is that just geothermal heating keeping it thawed, or what would...
So the best idea we have is a stronger greenhouse. So if the atmosphere had a stronger greenhouse effect, it could insulate the Earth and keep it warmer despite a lower solar luminosity. So that's actually, I have a paper that's in revision right now that's exploring like possible explanations related to metamorphic rocks for why there might have been more CO2 in the atmosphere on the early Earth and how that could help keep it warm even though the sun was dim. But it's speculative, I would say.
So Gohaku had a question. Have there been any studies to see how much radiation there is on Mars? Misadventure answered about 40 times what we see on Earth. Radiation could mean a few different things. Is that solar radiation or is that nuclear decay radiation?
Yeah, and so in terms of solar radiation, we are quite lucky to have this lovely magnetic field keeping us safe on Earth. And that's due to our liquid outer core that's convecting and generating a magnetic field. Oh dear. Mars does not have that. Mars does not have a strong magnetic field. So in terms of like solar radiation, a lot more of that is reaching the surface.
1/40th as much time to get a tan.
Yeah, there's...
Fair. All right, so we're an hour in. Do you want to keep playing this? Do you want to jump to something else? What do you want to do?
I feel like I am maybe reaching my memory limit of... I know if I get 100 coins, I can get a star that way, but...
Oh, you need to get that 8th star.
I think maybe it's time to move on.
All right, so we'll move on to... What do you want to do? Mario Kart?
Sure, yeah.
Okay. Go to the talking heads. In the meantime, we should put up... there's a question here. Not sure if this was asked, but is there actually water on Mars?
We've yet to find liquid water on Mars. There's definitely ice on Mars, but about a lot of what the recent rovers have been doing is looking for evidence of liquid water, either today or in the planet's past. So, like, there's certain things you can do with minerals to try to tell if they ever saw water. Things like swelling clays. The crystal structure of that mineral will change as it gets exposed to water. So we're like X-raying clays on Mars to try to figure out if they saw water recently. But as far as I know, we haven't found any liquid water yet. If it's there, it would probably be below the surface.
So Ecstatica wants to know, how much chemistry is there in your usual geology degree? I really like geology, but mostly in terms of ores, gems, or soil compositions.
So in terms of like...
Oh, wait, we transition out of games. Sorry. So Go Haku's talking shit. Is your guest running circles in Mario 64? Yes.
Yeah. Well...
Now she'll run circles in Mario Kart. It'll be fine. It's been 20 years and everyone's talking about geology on Mars while doing it Ecstatica or Go Haku, so we'll forgive her gameplay.
I'm happy for the break.
Yeah, no. Anyway, sorry to interrupt. How much chemistry is in the geology degree?
In terms of like chemistry department classes that I took at the undergraduate level, I think I only took wow, rough start. I think I only took one semester of chemistry in the chemistry department. Then in grad school, I took a couple other classes. But a lot of the classes that I've taken in geology departments are functionally chemistry classes. You know, like the class that I teach is basically, you know, it's just chemical thermodynamics. I think it's pretty similar to like PChem, that kind of thing. So in some ways what I do is applied chemistry, but I didn't take a whole lot of chem-specific courses.
I mean, that's curious because it seems like inorganic chemistry would be useful.
Yeah.
In terms of coordination chemistry, crystals, solid state.
Right. Yeah, and that is a lot of what gets covered in like a mineralogy class,
I see.
for example.
I guess you don't need the rest of it, right? You don't need transition metal coordination complex catalysis or anything like that. All right. Oh man. So going back to one from Shiesty. Actually, let's put up a prediction when I ask this one, because this is a heavy question. Which prediction do you want to do next?
Oh, why don't we go to earliest life? That's kind of on topic.
All right, ladies and gentlemen, we're gonna actually no. Let's go with this one because we just had a water discussion.
Yeah. Good idea.
That's right. I should have thought of that earlier. All right, we're talking about rocks and minerals and a whole bunch of geology-related terminology, but there is formalism in the community how you define these words, especially like they mean specific things. Pluto's no longer a planet because it's defined as such, or planets are defined in a specific way. And so geology has similar definitions, definition boundaries. So the question is, this is a true or false question. Ice, as in you take H2O and you solidify it into a solid, is a mineral. True or false? Does it fall under the definition of mineral? If you're not following us, click the follow button, get your standard internet units. If you have your standard internet units, bet on this question with your confidence interval of whatever amount of internet points you want to bet on each of these answers. The question is, ice is a mineral, true or false? Anything you want to add to that, or is that...
No, it seems good.
That captures it? All right, so make your guesses now. All right, in the meantime, Shiesty wants to know, was the amount of CO2 evolution due to the Greenvillian orogeny enough to change the global climate?
I think that is
So
like...
can you translate some of those words first before answering?
Yeah, I think some important context is that might be like word for word abstract I've written.
So somebody looked up your
Yeah,
page.
So let's see. Amount of CO2. What was the rest of it?
Due to the
So Grenvillian.
orogeny.
So orogeny is related to like orogenesis. Oro meaning mountain, genesis being making. So orogeny is mountain building, basically. So the Grenvillian orogeny is just a specific instance of mountain building. This one occurred about 1 billion years ago in the eastern part of present-day North America. And so the Grenvillian orogeny, most of those rocks in the US are buried where we can't really reach them, but in Canada they're exposed at the surface. So we have rocks in Canada that were metamorphosed during the Grenvillian orogeny, during Grenville age mountain building about 1 billion years ago. And so then the question is, was the amount of CO2 released by that mountain building event enough to change the climate? And the answer is, we'll see. So my current, one of my current field campaigns is in Ontario, looking at rocks from that time period, trying to estimate how much carbon was released by these high temperature metamorphic reactions, and see what it might have meant for climate.
Wait, so was the title of your paper a question, or was it?
So, I mean, this is actually, it's like a AGU an abstract. So I don't really remember.
No worries. Thank you, Shiesty, for digging deep on that one. That's one of those, like, I don't know if you've seen the YouTube hot ones where they like really dig into your history.
Yeah.
And find, this is the science equivalent of that. I'll ask something very specific. All right, Emily, is ice a mineral?
Yes.
The answer is true.
True.
All right, so what's the definition of mineral?
A mineral is a naturally occurring inorganic solid with a definite chemical composition or range of chemical compositions and a crystalline structure. So ice is naturally occurring, it is solid, it is crystalline, it meets all of the criteria.
So we don't have to declassify. This is a mineral. Sorry, Pluto fans. So water is a mineral.
Well, ice is a mineral.
Ice is a mineral. Yeah. When you solidify H2O, it's a mineral. Which is a weird way to think about. Yeah, I just, that never crossed my mind until I saw you put that question there. Yeah, that makes sense.
And then there are other things that you might think of as minerals that are not quite minerals. Things like opal. Opal is like silicon dioxide, but it's like quasi-crystalline or pseudo-crystalline. It's not quite a perfect crystal structure, so it doesn't meet the definition of a mineral. It's what we'd call like a mineraloid. So opal, not a mineral. Ice, yes, a mineral.
All right. Luke Sky Pacer. Do you deal with a lot of zeolites in your CO2 work? My work is in solid state NMR of inorganic materials like zeolites, nanoparticles, and using NMR of zeolites to study CO2 capture and ion exchange mechanisms is a huge thing, especially for researchers interested in climate science and stuff like that. So do you deal a lot with zeolites?
I try not to. So zeolites in metamorphic rocks tend to form at very low grade conditions. So just like you're barely metamorphosing something, it'll grow zeolites. And so they end up being really complicated systems that are difficult to study. So I haven't personally worked on zeolites much at all. But I know they have like really interesting properties in terms of like those holes in their crystal structure, right? And you can kind of like, you can put stuff in their little crystal cage holes.
Well, it's like things like hydrogen storage or gas phase molecules or CO2 sequestering, supposedly. Right. I mean, so that's a non-trivial contingent of energy research, is trying to extract CO2 from the air and basically seal it in rock. Yeah. I mean, that's the analogy to what you do, but they're trying to do it on a short time scale. Is there any relevance there?
Yeah, so I do have a student, Miles Kelsey, shout out, Miles is actually a post-baccalaureate who's about to start a graduate program. So Miles has been studying natural carbonation reactions because those reactions do happen in natural systems, just probably slower than we need them to happen. But we still have a lot to learn about, like, how do rocks become carbonated and kind of like soak up that CO2 naturally. So they've been doing some research on some rocks that are actually from the Florida basement. The Florida Geologic Survey has a core collection in town where they keep a bunch of drill cores. So these rocks are from about like a mile underground. And there are some basaltic rocks that are now completely full of carbon. And so we're trying to understand how the carbon got there and what the kind of reaction mechanisms might have been as a potential analog for like people who are deliberately doing carbon sequestration to fight climate change. So I'm definitely not capable of kind of thinking about the engineering work required to expedite those reactions, but studying the reactions themselves is like definitely an interest of mine. Yeah.
I mean, it's one of those so I work in solar cells, right? In
Right.
the photocatalysis domain. So I see some of this energy research on a tangent to what I do. But the idea of extracting CO2 from the air alone is a hard problem, right? Like if you have a super concentrated concentration of CO2, you can react it a bunch, but it's in the gas phase, the concentration is low.
Right.
But I mean, on a geological timescale, that doesn't matter, presumably. It's just slow sequestration and release.
Yeah, I mean, on geologic timescales, most of the carbon that is stored in rocks is stored in oceans. So it's actually dissolved, usually as I think like bicarbonate ions dissolved in seawater. And then today it's mostly biologically mediated. So like little crabs and critters build their shells out of calcium carbonate and they're taking carbon out of the water when they do that. And so the carbon that's in the water got there from the atmosphere at one point in time. So it's really taking like kind of low concentrations in seawater in most natural carbonate building settings on Earth. But that's what's kind of cool about the work Miles was doing, is that was an unusual setting that was like hot and underground and kind of maybe more useful to what humans hope to do someday.
So I want to point out to everyone that you're tearing it up on Mario Kart right now. How long has it been since you played this one?
I don't, it's definitely been more recent. I mean, I think basically, so I was probably like 5 or 6 when that last game came out, so I'm probably playing it with the skills of a 5 or 6-year-old, whereas this one's more like maybe middle school age. So I have a little bit better memory.
I have to commend you on your game choices, because you are, despite having, this is I think the 82nd stream, you are the first to play Super Mario 64 and the first to play Mario Kart Double Dash.
Really? Wow.
So we've played pretty much every other version of Mario Kart.
Yeah.
From like the original SNES to Mario Kart 8.
Nice.
But yeah, this is the first Double Dash. And GameCube was a bit of a bastard child of the Nintendo companion.
Yeah, it's probably my least favorite. Well, I never had a Wii U, so maybe I've heard that one was not great.
Yeah, that one hurt too. I got a Wii U to play Mario Maker, actually.
Okay.
But yeah, now Switch is doing well though.
Yeah, I'm a Switch fan. It's like the only console I currently own. So.
Ecstatica, we can do a lot of things like removing CO2, desalination, and other sci-fi stuff. It just takes a lot of energy. Yeah, that's exactly it.
Right.
Unlimited budget, you can do a lot.
Right. But yeah, if it takes energy, is it going to be a net
Yeah.
boon? Or are we just making things worse? I mean, so the biggest kind of example of this is in Iceland, the Carb Fix project, where they're pumping stuff down into the basalts on Iceland, and they already have a lot of energy because it's volcanic, so they have all this geothermal heat around. So that's, maybe a setting where it makes sense. They've got the right kind of rocks and they've got a lot of energy to burn, but Yeah, I think it remains to be seen whether this is like scalable at all, right? And then there are kind of more passive things people are looking at in terms of like just, you know,
You can punch in this game?
I guess so.
Princess is swinging at, is that Baby Mario?
Brutal.
Oh. Yeah, I didn't know about the whole 2 question mark boxes. I don't think I've seen that in other versions of this game. That's kinda cool.
Yeah. So, I mean,
dash.
mostly, so you can also play with 2 people on one car.
Interesting.
So you can kind of take turns driving versus the person in the back. Well, the person in the back can help you get blue sparks when you slide, which gives you a little boost. And they can shoot items. But I remember once playing with my older sibling. So Paul's like 3 years older and was always much more skilled at every game we tried.
Yeah.
But we like did the whole game with Paul driving and me in the back throwing shells.
I mean,
But
that's slightly better than the controller that doesn't work.
Right. It was really fun.
Well, Paul is not on Ask a Scientist Gaming, so take that, Paul. Emily's made it on Twitch in the gaming world. That's fun. You have weight classes that are determined by the total weight of your characters, so if the combined weight of someone you clash with is greater than yours, they will push you away.
I see.
Wow.
Yeah, I knew that weight was a thing, and so the smaller characters tend to have faster acceleration for that reason.
Yeah.
But
And there's differences in top speeds and
Right, yeah.
I think that goes back to the original
Right.
Mario's. Like the Donkey Kong and Bowser were the fastest, but Toad and Koopa were fastest acceleration.
right, which when you're a low skill player is more important.
Yeah. Speaking of geologic timescales, NARC, dare you. Emily's going to do great at NARC. It's
Yikes.
not going to take 86 hours.
It could.
I should have made him use the Mad Catz controller. Oh, do you remember those? The generic off-brand?
Yeah, we didn't have
Controllers.
those. Maybe we did. I don't think so, though. We had a bunch of controllers, but they like would have let me play a lot. They were a good
Well,
older
correct me if I'm
sibling.
wrong, but GameCube, it had 4-player options. Well,
Yeah, we could have played simultaneously, but then I wouldn't have won.
the acceleration is always better. It doesn't matter if you have the highest top speed when you are constantly being barraged by blue shells and a bunch of other BS that stops characters. And you have to start from 0 speed. Yeah, does this one have rubber banding? I don't know if you're familiar with that term. It's basically where if you're behind, you get things.
You get better items if you're in last place.
Yeah.
Yes. Right,
So
that's why I'm just getting a bunch of bananas.
Just
Oh,
too good.
there's a-
There's a mushroom. We count
Well,
those.
that's good.
All right, so we should put up another prediction because we've been talking about CO2, and this one's actually perfect. And so we're going to put up another prediction. If you're not following, follow us so you can get your standard internet units that you can spend on our channel for requesting factoids, making us take a drink, unlocking emotes. But you can also use them to gamble on a science question. I'm going to pop up a science question on the screen. It's going to give you 2 minutes to answer this question that Emily wrote for you guys. And the question is human CO2 emissions versus all geologic sources. Is this geologic sources over all time or
Like rate, so per year.
per year versus geological sources? Is it greater than 100 times or less than 100 times? As in, is the human contribution to CO2 emissions 100 times greater than all geological sources, or 100 times, or less than 100 times? Greater than 100 times or less than 100 times? Again, the answer is not exactly 100 times. Go Haku.
Probably.
Question for you, Ken. How much longer are you streaming? I need to go order dinner. We'll be on till 11 tonight. So if you want to catch NARC, that'll start at about 10:30. But yeah, we'll be on till 11. No matter what, we'll be at least till 11, depending on how long Emily takes on NARC. But, yeah. So enjoy your dinner. Come back. Have questions ready. We'll talk some geology, CO2 sequestering and emissions, and whatnot. So this is average geologic sources. So yeah, human CO2 emission versus all geological sources, greater than 100 times more or less than 100 times more. Got the power slide down. Well done.
Yeah, it's coming back.
Don't know how to vote. Usually the wisdom of the crowds dictates the winner. Sometimes we've had some dark horse bets where it's like 200 to 1 payouts for the less likely answers. So, yeah. Use your instincts, use your best judgment. And what is it, 100 times, greater than 100 times more or less than 100 times? CO2 relevant question. All right, 5 seconds, get your answers in. All right, Emily, what is the answer?
So it's greater than 100 times more. So
it's unquestionably greater
yeah, I
than
mean,
100.
so we do, there are uncertainties on all of these things and they're changing. Right, obviously human emissions are changing all the time, but our best estimates for how much carbon is coming out of geologic sources is that it's less than 1% of what humans are emitting every year. There have been, periods in Earth history when things were different, like maybe during a mass extinction event, Earth's CO2 emissions got pretty high. But in terms of like baseline, like what's happening today, geology is about less than 1% of what humans are emitting.
That's a depressing prediction.
Sorry, guys.
No worries. We need to know this stuff. I mean, especially, in Gen Chem, I cover like ocean acidification, which is the underspoken aspect of CO2.
Right.
It's not just climate change. It's also changing the acidity of the ocean.
Right.
Dissolving rocks in the ocean or, carbonates and things like that.
Yep.
So, yeah, this is a precarious balance.
So, and it's because my research is about natural sources of carbon dioxide, it does sometimes get kind of misappropriated by climate change deniers who want to say, look, there are all these natural sources we haven't been accounting for, that's what's causing, human-driven climate change. So I always try to make sure that I preface my work with, this matters on like millions of years timescales. This like metamorphic stuff matters. Compared to what humans are doing, it's minuscule. And like tripling our best guess for like metamorphic CO2 sources would not have any effect compared to human CO2 emissions.
What I hate about that discussion is even if you give those qualifiers, that was a banana
Ooh,
peel.
yeah.
How did that happen? Is this, so you said greater than 100 times, but what's the exact number? And if you don't have an exact number, you don't know.
Yeah, we don't know.
Yeah.
We don't know exactly.
We know it's a lot.
We know it's a lot.
Yeah. But they'll try to take that uncertainty and exploit it for their own ends.
For sure. Definitely. But it's, everything is uncertain. And I think it's really interesting if you look at like the IPCC reports of all the like climate change scientists who get together to talk about climate change and what's happening. The language that's used to try to communicate to a non-expert audience is always very strange. If you're used to like reading scientific literature, there are these categories of like virtually certain, or like it's virtually certain that humans are driving climate change. I think in science we accept that everything always has some uncertainty associated with it and don't think that means it's meaningless, but trying to communicate accurately about uncertainties but without giving the sense that like we just don't know anything is I think a real challenge.
Yeah, and we have to be very meticulous with our language too. It's
right.
Like this suggests, this indicates, this points
right.
to.
This may mean right, but like that doesn't really work.
Yeah.
When you're trying to say, hey, we really have to change what's happening.
We're really, 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 really sure, but not 100% sure.
Right.
Beyond a reasonable doubt. I like that language.
Yeah.
That's good enough. That's fun. All right. If you guys have any questions for Dr. Emily Stewart, she's happy to answer them. We're talking geology, plate tectonics, CO2 sequestering, talking about the surface of Mars and Venus, and we've gotten a lot of places. CO2 capture and whatnot. Yeah, if you have any questions, we're happy to answer them, or do our best to answer them at least. Using human language to describe anything is problematic. We don't exactly have a choice, misadventures. Oh no, Ecstatica knows who I am. Dr. Hansen's favorite word during scientific presentation, this proves. I tear people apart when they say this proves.
Oh, really?
Yeah, peer review, I have a copy and paste. It's like, I encourage you to remove all instances of prove.
Right.
You guys can hear my rant, but
This suggests.
yeah, we don't get to prove anything in the science.
You can prove a negative.
That's true, like a null hypothesis, which is disproving, but
Right.
you never get to prove anything, and that's the problem with. So you can prove stuff in mathematics and philosophy where the axioms are known, the rules of the system are known. But in the sciences, we don't know the rules, we're establishing the rules, and so we never get to prove anything, we only get to disprove things. And so, yeah. This proves that Ken hates the phrase, this proves. Yes. If we define the axioms of things Ken hates, yes. Proves is one of them. Shiesty, which LIP is the best?
So LIP here, I'm trying to figure out who this is. Is that...
Somebody you know for sure.
It's
but
definitely somebody I know. I have some guesses. J?
you don't have to own up to it, Shiesty. You
Yeah.
can just keep it anonymous.
Yeah.
So what's LIP?
So LIP stands for Large Igneous Provinces. So a large igneous province is exactly what it sounds like. It's like would have been an enormous volcanic eruption at some point in Earth's history. So we're talking about things that are like, I should have these numbers off the back of my head, but I don't. It's, you know, maybe 100 to 1,000 times bigger than the like Yellowstone supervolcano. So really, really big eruptions that last, you know, tens of thousands to hundreds of thousands of years and erupt hundreds of thousands of cubic kilometers of magma, lava, I guess, when it hits the surface. And so there are several large igneous provinces on Earth. Right now, I have students, in particular my student, Lindsay Ullman, my PhD student, is studying the Central Atlantic Magmatic Province and its proposed relationship to the end Triassic mass extinction event. So I guess I'd have to say the Central Atlantic Magmatic Province is my favorite, since it's the one we're working on.
What I love about this question is they didn't ask your favorite. They asked which one is best.
Oh, well, yeah, well then I guess it means what you best. Yeah, so that's right. That is a more objective. So best, the biggest volume is, I believe, the Ontong Java Plateau, which is underwater. So you could argue that that's the best one. But the one associated with the biggest mass extinction would be the Siberian traps, which erupted during at the end Permian mass extinction, when something like 90% of all life on Earth went extinct.
Oh no.
So
So it depends how you feel about mass extinctions.
right.
Whether it's the best
Are
or
you
worst.
pro mass extinction? If so, then I think the Siberian traps are your...
That's amazing. Tasty strikes me as pro mass extinction.
I suspect so.
Does that tell you who they are?
Ooh.
Stalin has entered the chat. Stalin's back again. All right, we're coming up on 9:30. Anyone just joining us, Ask Science Gaming, mediocre gameplay, expert science. Tonight we have geologist Emily Stewart, who is answering questions about carbon cycle in deep time, as well as carbon sequestration, metamorphic rocks, plate tectonics. We've been a lot of places talking about Stalin a bunch. Interesting.
Always.
Always. It's one of those rules of the internet, right? Give it enough time, Hitler or Stalin will make it into the chat.
I don't want to out myself as a tanky, so I'll just keep quiet.
That's fair. Oh, that's fun. Those.
Oh, no.
If you run into those, they turn you into.
I wouldn't... Fun is not the word I would use.
No, it's a mineral. It's fun. Cuddle Puppy. Does finding modern memes annoying mean you're officially middle-aged or older? Oh man, I doubt that's even middle age anymore.
I love memes. I don't know what to say.
I mean, I'm not even up on the like Gen Alpha meme.
Oh, I don't think I am either.
Yeah.
I like put memes in my PowerPoint slides, and sometimes the students laugh, and sometimes I can tell that they just feel sorry for me, which is the worst response.
Well, that was something hard for me, like especially teaching. Is like there was this phase where I could make like Simpsons jokes, and those would be topical. But like you age out. I don't know.
Yeah.
I mean, I'm sorry, I don't know Pokemon. I just don't. And that's already 10 years too old. So yeah. But those stupid TikTok songs they put on every video they show, yes, that is true. I can be against that. Does it mean you're middle-aged? No, it might mean you're 5 years older than the person producing it. So it goes. That's when you double down. To make it as awkward as possible.
Oh, yeah.
Start using 1930s memes. Man, that is amazing. All right, we're at 9:30. Do you want to change games? Do you want to get to some of your other ones? Or it's up to you. We'll start NARC at like 10:30.
I guess, let me finish this race at least.
Yeah, it's up to you. Whatever you're having fun doing.
Let's transition.
Let's enjoy it.
The other games I picked, Played Up might be beyond me right now.
That's too much while talking.
Two of them are like turn-based, which is maybe... Oh, am I going the wrong way?
Is this harder than you expected, or about the difficulty?
The Mario 64 was harder than I expected, but it was partly that I just didn't remember where any of the stars were.
Yeah, I mean, that one's non-linear, right? There's
a lot of options. This is going fine, I think. I did make second in the last race, which is too bad. But
still fall out the win. All right, so I'll catch up with one of my favorite questions. I've seen a lot of movies over the time and talked to a lot of scientists about movies, and so one of our favorite questions to ask is, what movie or TV show gets your discipline right, and which ones get it wrong? Which ones do you gasp at how terrible it is? Which ones do you say somebody did their actual homework?
There aren't that many geology movies. I mean, there are some, definitely. Some of they're like a lot of disaster movies, like San Andreas with The Rock is fun. Probably the worst science movie would be The Core.
There it is, Cuddle Puppy already said it. I was going to ask you about it. That's early 2000s, The Core. Do you want to recap?
It's
Spoilers
really
if you've not seen it.
Shocking. I think the
I can do the premise if you want. I remember the storyline.
Yeah, I know, like the core stops spinning or something.
But do you remember why it stopped spinning?
I know how they have to fix it, but I don't remember why.
So it's because they made essentially an earthquake machine. Like international warfare, they wanted to have this undetectable weapons. They somehow created an earthquake machine, and that earthquake machine stopped the core of the Earth rotating. And then, then it's the story of them trying to restart the core of the Earth.
Right, so they have to go down to the core and set off some nukes, I think, to get it going again.
Because that would make sense.
Well, they have to be precisely timed. But yeah, they go like hundreds of miles underground, and then there's this just like open space hanging out, which is like, the pore space at those depths would be like 10 to the negative 14 or something. Like it would be.
You're not walking through those.
There aren't like holes full of monsters. So that's pretty rough.
The Hollow Earth misadventure, yeah. Ecstatic triple red-shelled Peach and Daisy.
Yeah.
What did they do to you?
They almost beat me. Look, I beat them by a couple seconds.
Cuddle Puppy, I feel like the military-industrial complex dictates that the solution to every disaster movie is deploy all nukes. Well, they did restart the core and save the Earth, so... I mean, at least they were accurate in if the core of the Earth stopped, the electromagnetic field would stop and we'd get irradiation and
but
solar storms.
The birds just like fall out of the sky.
I do not remember that one. Oh, because they can't find north anymore.
Right, so they just forget how to fly.
Armageddon, also just nuke it.
Always. In terms of like movies that do geology well, I'm not really. I mean, I think like Jurassic Park like captures some. Obviously, there's a lot that's wrong that we now know is wrong. Like none of the monsters have feathers, you know.
Yeah.
But I think like the spirit of Jurassic Park is compelling and correct. Like the moment when the scientists like see the dinosaurs running around together for the first time, and it's like people who've been studying these extinct creatures for their whole lives, and they're like, they do move in herds, and it's like this like moment of awe. I feel like that is one of the best. Like that's exactly how you would feel if you had been like studying some extinct being your whole life and all of a sudden find out that your like pet theory was true. Like, so I like that.
No, ecstatic. I think she was saying that the dinosaurs in Jurassic Park don't have feathers and they should.
Right.
Like it's understood that now they do.
Right.
But and then Cuddle Puppy brings up the point: feathers are too cute. They look less threatening if they have to have feathers.
I haven't seen the newer ones, but I have heard that they like address that actually. That one of the scientists says like, yeah, of course they had feathers, but feathers look dumb, so we bred them not to have feathers.
Yeah. Because you can do that. I'm going to propose one that got it right and related to our question earlier. Have you seen Breaking Bad?
I've seen like the first season. I didn't finish it.
So his, I guess his, what is it, brother-in-law or something? He
Oh, they're minerals, Marie.
Yes, not rocks. They're minerals. Which was inaccurate.
Yeah.
Assuming they were all naturally formed. I didn't know natural was part of the qualifying statement.
Oh,
but
yeah.
He was very specific that they are in fact minerals. Is that a meme you've thrown up in class?
It comes up. I've never used it in class, but it definitely comes up not infrequently when you tell people you're a geologist.
It's pretty spectacular.
I guess also the dad in South Park is a geologist, so sometimes people mention that.
Oh, is he really? I honestly don't remember.
I
That's
don't
Randy
think-
Marsh.
Yeah, I don't think it is like that relevant, but just in terms, we don't have a ton of famous geologists, so we got to
we'll
take
take
what we
that.
can get.
Ecstatic has confirmed. Yes, Randy Marsh is a geologist.
Thank you.
That's a win for your team.
Yeah, I guess.
What he does, that's a good question. Like, what is your office job as a geologist?
Yeah.
That's amazing. All right, this is Star Cup. You're doing 50cc.
Yeah, maybe we can. Let's move on.
Let's transition to the.
I've
your
like
computer.
demonstrated that I can play one video game at least
No,
at
that-
50cc. So
We'll
that's
count those. We got GGs on that. All right, so let's transition over to your computer. Make sure this is still on and not asleep. Which lip is the best? Is it LIP or do you guys say lip?
we say lip. And so my favorite lip, the Central Atlantic Magmatic Province, people call it CAMP. So it's everything's abbreviated all the time. Let's see. Maybe some Monster Train.
And these are games you play now?
So I haven't played Monster Train in a couple years, but I went through a big Monster Train phase.
Wait for that to pop up. Oh, it's contemplating. Guess I should have thrown a question up there. All right, so we got the core, we got Jurassic Park, we got Breaking Bad. Anything else geology related? I guess we talked about some disaster movies.
Yeah, San Andreas. Yeah, Dante's Peak is classic.
Dante's Peak. What was the other one that came out? There were two volcano movies at the same time.
Oh, was
This is
there?
like late 90s.
Yeah. I don't know if I
Volcano.
Volcano, right.
Volcano and Dante's Peak.
Yeah.
Radbeard, Superman nukes into the fault line. Which Superman was that? No, he goes around the Earth backwards to reverse time. I don't
Does he
remember
do that on purpose? There's like, there's something where like Lex Luthor wants to like nuke the fault line to make his property oceanfront property or something.
That's amazing. What's the one where there's like an active volcano in San Francisco or some city like California? I think that is volcano. And they like, to divert the magma, they like blow up like buildings to try to like make a path. Like
Which is actually like a way that you deal with lava flows. You build like dams and just try to redirect it. So I'll accept that.
It's a fluid dynamics problem.
Yeah.
Superman. Oh, the original Superman. Bradbeard, welcome to the stream. Thank you for joining us. If you haven't clicked the follow button, you should. But yeah, if you have questions for Emily related to Superman and nukes, a lot of nukes. Stalin and nukes was our tangential geology journey tonight. So if you guys have questions, Emily is happy to answer them. We'll put up predictions in a little bit. I'm going to grab the proof beer if you want to give it a try.
Yeah, that'd be great.
All right. Twice. How could you write such and why?
Is that you, Paul? This is a how could you write such a why? This is from Stephen King was like listing some very strange fan questions that he had gotten.
How could you write such a why? That's an amazing sentence to a prolific author. All right. If you want to tell people what this game is, for those that aren't familiar, I'll grab some beers.
So Monster Train is essentially a deck building game. And you have different factions, and you can have two factions. And I have almost exclusively played as this guy, Tethys, and you'll see, but that's kind of the gist. I might take it down. Let's take it down to a easier level. See, I'm playing on my partner's version of this game, and he only made it to level 21. But I just wanna, yeah, it is similar to Slay the Spire, yeah. But yeah, let's go. I think we're trying to like rescue some hell creatures or something. So it's been a while, but there's a boss and a bunch of like smaller things first. So let's see.
All right, it's Flamingo Party Tropical Blonde Ale.
Okay.
I tried this. Have you seen this before?
I don't think I've had Flamingo Party. I've had Garden Party from Proof, which I really like.
Pretty sure this is a sour. I know it's fruity at the least, but I remember it being sour. If you hate it, don't worry. You don't have to drink it. You don't force alcohol on anyone. Nerd. That's a great start.
And proud.
Tropical Blonde sounds like it caused skin cancer. Yeah, there we go. I like it. All right, do we have sound on this?
I don't know. I think I have the volume completely down.
Might be possible. It's not even. Let me unplug and plug that back in. All right, there we go.
All right.
Yeah, some reason the video capture. So we have It's weird. So what we do to capture these games, so Emily brought over a computer. We have an HDMI going to my monitor, and then I have a out from the monitor to the capture card on the computer. So it is a mess. Sometimes it misses the, oof, that was loud. Oh, God. Sorry, any headphone users, I apologize for making your ears bleed now. I did not expect that volume jump.
So this like shard of the pyre is your kind of base that you're trying to defend, and then there are 3 levels. The enemies will like move from the bottom to the top and try to get to your pyre and kill it. And then it's been a while, but generally you don't want your champion taking a bunch of hits, at least this champion. So I'm gonna put him here, I guess.
So this is weird. It's not like explicitly sour. It's got a weird sourish taste to it.
Oh wait, that's not what I meant to do.
All right, should we do... Speaking of gaming, we're going to do some Emily-based questions. Which one do you want to do? I do want... Well, this one's gaming related.
Yeah, we can do it.
All right. We're going to see what you guys learned about Emily through her Super Mario gameplay or Mario Kart related gameplay. God, that's jumping volume a lot sometimes. It's like it's quiet most of the time and then it goes crazy. Cheap Scientist redeemed take a drink. Well, cheers, Cheap Scientist. Cheers, Emily.
Cheers.
Thank you for joining me. Hopefully you guys have a drink in hand. Thank you for joining us on a Wednesday night while we drink and play video games.
Life's good.
Yeah, exactly.
It's summer.
Well, speaking of which, I got to change the name of the game we're playing. What's the name of it?
This is Monster Train.
How was that volume-wise? The attacks make it really loud.
I can also do something in here and change, like make sound effects less and...
Yeah, no worries. I'll adjust as we go. Did you increase the cost to take a drink? No, I think it's always been $500. Should I lower it? Like The Simpsons show, thanks. The audience is now deaf. I apologize, everyone. We did not calibrate the sound on this one. We kind of make it up as we go, so I'm sorry for that. But yeah, cheers to everyone. Hopefully you have a drink in hand. You just lowered it to 1. Try to find a middle ground. You may not be a student, but you're still in college. No, do like Spinal Tap. Go to 11. Yes, we really need Monster Train as loud as possible. That's how you feel like you've engaged with the game.
Yeah. That's what deck builders are all about.
Oh, man. All right, we're going to do a gaming question related to Emily, but it's going to be not a video game related question. I guess unless you do this on a computer, then I think technically it counts. All right, from what you guys have seen of Emily's Monster Train, as well as Super Mario Kart, as well as Super Mario 64, turns out Emily also does crossword puzzles, in particular New York Times Sunday crossword puzzle. And the question is, what is her best time in that crossword puzzle? Is it greater than 15 minutes or less than 15 minutes?
Did you say Sunday?
Yes.
Okay.
Yep. Yeah. This Sunday. Sunday's the hard one.
It's the longest one. Arguably,
one.
Saturday is harder, depending who you ask.
The question is, how long does it take Emily's best time? Not average time, best time. Is it greater than 15 minutes or less than 15 minutes? Which is an intriguing question. So presumably some of these people have done the New York Times Sunday crossword. I have not personally, so I have no metric for this. When I heard cross, my brain immediately jumped to crossbows. Now I'm really disappointed. Wait for the next prediction. Emily also has a crossbow hobby. I'm just kidding.
I did fence in college.
Oh, that's fun. Like it was a club or team based or?
Yeah, it was like a team. It was like it wasn't like NCAA. It was like a club level team, kind of.
And you started while in college?
I started in high school, actually. And then, yeah, in college. I did a little in grad school until when I got to Yale, I tried to take. They have an actual like NCAA team, and I tried to train with them a little bit, but I don't. It was kind of like a Mean Girls situation. They were just like I was like the weird elderly graduate student, and they didn't want me there, and I just was
brutal.
Yeah.
The politics of fencing. Cuddle Puppy wants to know, was it to the death?
Usually, yeah.
Misadventures. Nah, she just randomly went around poking people with a saber.
Epic.
Yeah, that's why she was the weird
Thank
person.
you.
It turns out it was a ping pong club and she brought a saber. Who knew? Sabers are slashing weapons, so it's perfectly safe. Wow.
Guess
But it was
I'm gonna get
the
this
point-based fighting, the Olympic style.
out. Yeah, exactly. Yeah.
I appreciate it, but it's so fast. It's hard for me to keep track
Even
of.
as a fencer, I think it's almost not worth watching because a good fencer is doing everything as small and fast as possible. So it's not really spectator friendly. And they've done like weird stuff to try to make it spectator friendly. They like made masks clear for a while, and then that was not really
And like the light up bodysuits on points. And
they've like tried, which I'll give them credit for that, I guess. But
well, the other thing is, I mean, the saber blade is thin enough that it's hard to see, right? And they're like bending it and wrapping it around, and it's like you just can't do it in real
and so
time.
if you can watch a stream that has like some slow motion replays, it can be worth it. But basically, I think it's not a good spectator sport. I actually think tennis is kind of the most similar. Tennis is like fencing slowed down and spread out to where you can actually see what's happening. You're like trying to draw your opponent into one area so that there's an opening so that you can attack in another area.
Yeah.
So
spatial control.
yeah, exactly. So
Yeah.
I feel like just watch tennis. I don't know. Unless I mean, I will watch Olympic fencing, but I don't.
Cuddle Puppy counterpoint. I prefer streams where they use great axes and halberds. Yeah, into LARPing. I do like the like medieval warfare. Have you seen any of these where they dress up in full armor? And just
There's
mash
like
the hell out of themselves?
a LARPing. Well, they're not in full. Oh, like on Twitch.
I mean, like ESPN Ocho when they do the like weird sports. There's people that do point-based fighting and all
I
sorts
haven't
of.
seen that. Oh, I'm gonna win. I can just. Yeah, I think they're a LARPing group that meets in the park near my house, and whenever I jog through on like Sundays, I see them. But they're doing it with like foam and kind of stuff. So I was a Dungeons and continue to be a Dungeons and Dragons player, and we always drew a very firm line between ourselves and LARPers. But I think realistically, that was not as firm of a line as we liked to pretend.
I mean, it's like the theoretician versus the experimentalist, right? Like
Right.
on paper, you're in. But executing. So that's interesting. Did you find a D&D group here?
No, but if anyone has any suggestions.
Ooh, I've had a bunch of people on. Jeff Kahn, the law department, apparently has a bunch of people that do D&D.
Okay.
Yeah. I can email Jeff if you want.
Yeah, that would be great. I think, D&D is such a weird, it's become a lot more like diverse, I think, over my lifetime. And there's some people who really cling to the old ways and really want to do like a very crunchy game that's all about like winning the fights. And that's like less interesting to me than like a very role-playing, heavy, like storytelling kind of D&D. So it's hard to know ahead of time, like which kind of
you fall under.
group you're getting into. Yeah.
Cuddle Puppy. So do D&D players bully LARPers, or is it the other way around?
No, we bully LARPers. Yeah. And fencers also like tend to have a chip on their shoulder about like, we're not LARPing, it's different. Like,
It's a sport.
but
Athletes.
which like, I'll be honest, like I see the similarities. But
But the reaction time is ridiculous, so we'll give it to him. All right, let's answer the prediction. Emily's best New York Times Sunday crossword is greater than 15 minutes or less than 15 minutes. What is your...
it is more than 15 minutes. Unfortunately, it's 15 minutes and 15 seconds.
Oh, no.
So it
That's
was
like a bar you set for yourself? That's...
Yeah. I was trying to figure out how to humble brag this one, so I felt like I had to like set expectations high.
That's amazing. Somebody kind of called that out. What was their is Emily the boasting type? Hard to say. Maybe less than 15 minutes. So this was a humble brag.
Yeah.
15.
I hope I threaded that needle.
Yeah. So 15 minutes, 15 seconds. So yeah, greater than. She tied my record at greater than 15 minutes. We could have put exact times there, but we did not. All right. Anyone just joining us, Ask a Scientist Gaming Mediocre Gameplay Expert Science. Our guest today is Dr. Emily Stewart. She's an expert in geology and plate tectonics and metamorphic rocks, how those rocks change over time, and modeling that behavior and doing actual field work related to geology and such. So if you guys have any questions related to that, anything else you want to talk about? We have more predictions we can throw up there. I don't want to miss anything if you want to.
Yeah, I feel like I like the pun one. If you want to pull that up, I think it's late enough.
I'm not sure how many people will get these, but we're putting it up there. That's fine. We're 2 drinks in.
There's got to be some geologist on here who'll appreciate it.
There's going to be one person that snorts aggressively with this one. So. I knew these puns were a thing because we have them in chemistry, but everyone has to cringe. All right, what's fun is you're going to explain these puns to the layman audience. So, all right, you guys, we're going to put a prediction up here right now. The question is, what is Emily's favorite geology pun? Do you want to pronounce these?
Yeah, so the first one is tough schist. And the second one is you breccia.
Which one is Emily's favorite geology pun? Oh, man. People responded quickly to that. They're like, I'm 100% sure it's tough schist. Put your predictions there. If you guys aren't familiar with the stream, Ask a Scientist Gaming, we don't do game predictions. Instead, we do science-related and guest-related predictions. And so this one is about Emily and her favorite pun. You can't really possibly know this, and you're not finding this on ChatGPT or Google, unless you have a history of expressing this somewhere on the internet. You guys are on your own, but you can bet as many internet points as you want, and this is mostly for pride, but also you can use those internet points to make us drink. You can request a factoid, unlock emotes, so on and so forth. I'm running out of points to redeem drinks. Yeah, points are valuable. Is my drinks price too high? Because we drink anyway, regardless of whether you guys say it or not. So, yeah, what is Emily's favorite geology? Is this something like faculty meetings? I guess you're in a weird department because you have everyone.
We have Earth, Ocean, and Atmospheric Science.
Yeah,
so it's got
like
a lot.
A quarter of the people are excited about puns. And the others.
I feel like we all have our own puns we care about.
Yeah. Do geologists research how to make diamonds quickly? That is interesting. Is that I know it's a chemistry/engineering problem, but do geologists go into the synthetic mineral market?
There's like a field called gemology that maybe would. Oh, I thought I was going to keep this alive, but I'm not. Oh well. I think gemology is arguably related to geology, and a gemologist would probably do that, but I do think it's more of an engineering kind of question. Mm-hmm. Unless, is there a natural environment in which diamonds are made extra quickly? A geologist would study that, try to understand that natural process.
I mean, so one place they might make headway is making these exotic, blue diamonds, red diamonds, chocolate diamonds, so on and so forth. I mean, insights into natural sources presumably lend some insight into that, but I don't know.
Yeah, for sure. I think one thing that's weird is that I think for the most part, buying natural diamonds is like not justified in my opinion. But one of the really valid reasons to buy a natural diamond is to do like diamond anvil cell experiments, right? So
Man, I should send you in Gen Chem. I have a rant against the diamond industry, and I make two columns like synthetic diamond versus natural diamond. Oh yeah, I diatribe. In fact, my end of semester reviews, like 5% of my reviews are, oh, I just told my girlfriend I'd never buy her a diamond and she cried. Like, oh, that's awesome, thanks. But no, don't buy natural diamonds. They're covered in blood.
Except for diamond anvil cells.
Exactly.
Right, because the defects in the crystals make them a little bit stronger.
Oh, that's interesting. The defects are...
They actually, right, it's kind of like if you think about the atoms almost like catch on each other is like the metaphor.
Yeah.
Like,
I mean, it's...
if you have a perfect diamond, it has more like planes of weakness that it can break on. Or that's what I've heard.
So it's like some leeway along fracture lines or something that...
Right, yeah.
That's interesting. All right, Emily, time is up. What is your favorite geology pun?
You breccia.
Oh no!
I guess I never. Oh really?
It's a 2.4 to 1 payout. Congratulations on who decided on you breccia. So explain those.
Yeah. So a schist is a type of metamorphic rock, which might lead you to believe that it would be my favorite geology pun. A schist is just a metamorphic rock that has a certain kind of layering in it that comes from mica minerals. So those are like often used for glitter, like the shiny minerals in makeup are mica minerals. So in a schist, those minerals are all like aligned in the same plane. That's what a schist is. Most schists are not actually tough because of that alignment. They break easily. But a breccia is I guess arguably, I mean, it's like a sedimentary rock that's a bunch of like kind of jagged pieces that get stuck together. Normally you would think of like pebbles get rounded by water, but in some environments, like in a fault zone, you can get rocks that get kind of like cracked apart and then re-cemented back together, and that's called a breccia.
You breccia. So why is that your favorite?
I just like, I feel like
breccia.
Schist is kind of like the most overused geology pun. If you're a geology person, you've heard like schist jokes every day of your life.
Yeah.
Since you started doing geology. Whereas you breccia, I feel like, is a little bit less well known. So, yeah, that's part of why I like it. I also just think it sounds funny.
You breccia?
You breccia.
Didn't Sarah Palin not ruin that for you? No?
No.
Yeah, so I'm originally from Minnesota, so that like Canadian northern border. Oh, you betcha.
Oh yeah. Oh, don't for sure.
Fargo, just screaming at you. You breccia. All right, you guys learned something about Emily today. Congratulations. Gohaku has a question. Are diamonds the hardest mineral? I remember hearing anecdotes about diamonds can cut many things.
Yeah, I think so. I'm pretty sure there's a mineral that is harder than a diamond.
What is that? Mohs scale? Is that the one?
Mohs, M-O-H.
Mohs.
But diamonds are like by far the hardest common mineral. And like obviously diamonds aren't common, but like they are more common than whatever that thing is that's harder than diamond.
And is that a natural mineral? That's presumably synthetic.
I think there is a naturally occurring substance that's harder than diamond, but I could be wrong. I'm not positive.
Let's see what Google has to say. Lonsdaleite?
Lonsdaleite?
Lonsdaleite.
Lonsdaleite.
Found in a meteorite.
Yeah. So, yeah, there you have it, folks.
So we defined mineral as something that has to exist on Earth or just exist naturally?
It has to naturally occur.
Okay, so
yeah, meteorites count. Yes.
And that's fun. So a meteorite could crash to Earth tomorrow and we'd have like 20 new minerals from synthetic things that we've had. That's fun.
And then there are these phases that we are like 99% sure exist naturally on Earth, but the way the current kind of guidelines are written, we have to actually observe them, like with X-ray diffraction or some other technique, to give them a mineral name. So things that we can model. So most of the mantle is made of this mineral called olivine. It's like the mineral that makes the sand green on Hawaii, and it's like a lovely mineral. But we have like modeled and then also recreated like through diamond anvil cells in a lab, like what will happen to that mineral when it's at higher pressures. And so we think, you know, the vast majority of the mantle below a certain depth is made out of this like mineral with like there's perovskite and then something we call post-perovskite. But because no one has seen that mineral in real life, we can't give it a mineral name, even though we're pretty sure it makes up like a huge percentage of the earth.
So this is turn-based?
Yeah. So the enemies, like, you basically you get like one attack and just the front unit gets attacked. So like we'll get 3 attacks against their front unit. They'll get 3 attacks against my front unit. But if that unit dies, you know, the next one will become vulnerable, and then they'll move up to the next level. So this is actually kind of a problem because right now he's not gonna die on this level, which means he'll make it up to my pyre and start dealing damage there. So I'm gonna kill him with like a spell. But that was all my like mana, so.
I was thinking of kryptonite. What's a natural occurring mineral that's harmful to humans?
Oh, all kinds of things.
Yeah, anything with radioactive alpha decay, presumably, or...
Yeah. Right, uraninite would be a big one. Uraninite is like a uranium ore mineral. But also asbestos is I mean, asbestos is actually a term for like something with a certain shape, essentially.
Yeah, it's
but
like rods.
a lot of asbestos is a mineral, actually. So,
Yeah, but that one's it's a size and a shape and not a composition issue.
right.
It gets
Yeah,
in your lungs
exactly.
and shards.
But there are lots of like asbestiform minerals. I'm just gonna let that guy get to my pyre, I guess.
So one thing I use to complement my rant against the diamond industry is my rant against the healing crystals. Do you have any strong opinions about healing crystals and minerals that have various powers associated with them?
So I actually don't, and I think like if people are able to kind of explore like spiritual concepts with respect to minerals, that's totally fine with me, and I'm happy for them to do that. I'm not like willing to have the scientific conversation about it. I think, you know, it's a different realm of. I'm actually doing really badly here.
Oh no.
I'll just let this train steward die. Oh no, see, because they attack first, so that was actually pointless. So, yeah, I think when it bothers me is when people kind of will try to like ascribe some kind of scientific significance where there is none, but it doesn't bother me if people have like spiritual connections to minerals. I think that's fine.
Well, that's one of the qualifiers I give. Like, if you want to do this and if placebo and makes your slightly, you know, achy wrist feel better by putting a rock on it, by all means do so. My only concern with it is when you start like choosing that over a cancer treatment for your kid.
Right. Yeah,
like,
exactly.
There's a threshold of acceptable, you know, whatever non-scientific, pseudoscientific application of that. But the one thing that I like to discuss with that is like, if you're going to heal the body, you need to manipulate the atoms within the body. Like, that's just it, right? Whether it's drug delivery, whether it's photodynamic therapy, you have to do something to those atoms. And what I love most about, you know, putting quartz on somebody's chest and it curing cancer is they're basically proposing that there's some fundamental physical force that we have never quantified or observed before that's making that happen. And so, like, the scientific claim behind that, like, well, like you said, when you get into the science behind it, what would have to happen for that to be real is profound. It would change. It goes beyond strong nuclear and electromagnetic and gravity to have something new that's a byproduct and no scientist has ever seen before. That's, yeah. Sorry about the diatribe. I have a few in Gen Chem that I do. One is the diamond industry, the other one's healing crystals, which happens to be related to your expertise. So I apologize.
Yeah, no worries.
Gohaku Gemology got me thinking about the Gem cartoon from the 80s. Oh yeah, Gem and the Holograms. It's a music group, right? That like fights crime or something.
I don't know it.
You are probably too young for that. Seconder, how far does statistical mechanics get you in geology? Oh, that's interesting.
I took a statistical thermodynamics class in grad school that, I mean, it is really useful. Like, I mean, in terms of like predicting mineral stabilities, the concept of entropy is really important, right? So I don't know if that's a good enough. There are like some really useful concepts there, and I don't think I ever really, right, in like a kind of classical thermodynamics class, you don't really learn much about what entropy is. You just kind of like learn that it's this thing that's conserved and it's got something to do with disorder. And so like approaching that in like a more statistical mechanics way, I thought was really illuminating to just kind of think about like possible configurations, like Boltzmann stuff. But so I feel like maybe functionally, I don't like think about statistical mechanics much, but I think like we gain a lot from it in these like kind of thermodynamic ways.
I mean, anytime Boltzmann's constant shows up in an equation, you're using it, just not explicitly, right?
Right.
Like it's there.
It's a number, right?
Yeah. All right, Gohaku, where is arsenic found in nature?
Oh, you know, I'm not sure.
Are there arsenic minerals?
Yeah, there are arsenic minerals for sure. I want to say like arsenopyrite is a big one. So that's the arsenic sulfide. So sulfides form in a lot of different environments, but maybe there's like things called volcanogenic massive sulfide deposits. So like around volcanoes, you get like pyrite. If you ever heard of pyrite, that's fool's gold. You know, those like little gold cubes. That's an iron sulfide, but you can get arsenic in that. So the main arsenic mineral I know of is arsenopyrite, which I would assume forms in similar settings to like other sulfides, which would be sometimes these volcanic settings or in like maybe anoxic ocean settings. But I'm honestly, I've never thought about that question. So
according to a quick search, arsenic is basically everywhere in the crust. It's just evenly distributed throughout. It's not like concentrated and mined. And it actually shows up in a lot of like vegetables, mushrooms, rice-based products, such as baby foods. And it's, I mean, pulled out of the ground apparently.
very cool.
Yeah, exactly. I mean, but in small doses, it's not bad, right? It's a concentration curve related thing.
Yeah, well, it's true of literally everything, right?
Yeah, water's fine until it's too much.
Right.
Then you drowned. Well, that's the other thing we deal with a lot in chemistry too, is like mercury is a swear word, right? But there's certain forms of mercury that are very bad, things like dimethyl mercury. But liquid mercury is not that bad. It's relatively okay. I wouldn't recommend drinking it, at least not as much as they did back in the day. But
Right.
man, the other one that's are you familiar with what's the name of that dye? Prussian blue. The iron cyano crystalline lattice. It's a blue dye discovered, I don't know, 1,000 years ago. It's what's in the famous painting The Waves off of agawana or whatever I don't remember the name of it, but
Oh, yeah.
yeah, it was a blue dye, but it has this, it's an iron cyanide. So you have two iron centers, one's iron 2, one's iron 3, and you have a cyano bridge between them. And it's literally has cyanide in it, but it's cyanide in a crystalline lattice, and it's fine. It's an awesome blue, vibrant color. But as soon as you pull that cyanide out alone, all of a sudden it's toxic. And I imagine, I mean, arsenic is another example. As long as it's in the crystal lattice, I imagine it's fine. Until you dissolve it in the bloodstream.
Right.
And lead paint chips. Exactly. Still can't believe there were mercury dental fillings. Yeah. So how, going back to health concerns, how concerned are you when digging for things that you'll randomly come across something that could be damaging to health?
Oh, basically not at all, I guess. I mean, most of these things, it's like you said, like the amount you would need for it to be a concern is beyond what you would like accidentally spend a long time around. I think
Geologist YOLO.
but actually
it's more risky. You might fall in a hole or smash your hand with a rock hammer.
yeah, I mean, the most dangerous thing you do as a geologist is work on the side of the road by far.
I mean, that's a fun question. Well, maybe not fun question, but one we ask is, what's the worst mistake you've seen, or the most damaging, most expensive mistake you've seen, field work or lab work or otherwise?
I mean, I've seen like damage to the order of like maybe 6 figures on a mass spec when there was a power outage. That was a bummer. So that's probably
The most expensive.
the most expensive I've seen. And we had like a backup power system that lasted for like a couple hours, and the machine should have been put into a lower power mode while it was still on that backup, and that did not happen. And then it vented. It's under vacuum all the time, and it lost vacuum and was down for months and months.
That kills all your columns and all your. Oh my God, that's brutal.
Yes.
As far as injuries, field work, anyone getting twisted ankles or?
Oh yeah, I mean, definitely. People like. I'm trying to think if I've actually seen any bad field injuries. I've like heard stories, but I don't think I've actually like seen much, I know my PhD advisor like absolutely like wrecked his knee on a field trip once, and like oh wait, what did I do?
Oh no. It's unfortunately you know this game and you want to win, but we're going to keep asking you geology questions. If you guys want to distract Emily and destroy her gameplay, now is the time.
But
It's fun.
yeah, sorry, what was
Biggest injury? It's your advisor, knee injury.
yeah, that like put him out of commission. I know people who've like, I think same advisor actually like broke his thumb in a hammering accident. So it definitely, there are unfortunate things that can happen, but I've been pretty lucky actually. I take field safety pretty seriously, I guess. Like,
I mean, so you have to train your students along that vein then too.
yeah, definitely. And so like my biggest things are like you gotta wear eye protection when you're hammering. Like people have rock chips fly out
my
of them and hit you in the eye and you go blind. So like it's really hard to be a blind geologist. So always wear eye protection when you're hammering, and always pull your hair back if you're doing work with like a rock saw or any of these like things with spinning parts. Having your hair down is bad. So those are like the main ones I harp on a lot.
That's pretty awesome. Misadventures. Twitch has helped me rediscover my interest in geology.
Oh,
Yeah, most people think Twitch is just video games, but there's a really healthy science contingent. One of the geologists I know of, Rocket Sage, Misadventures. If you haven't checked out Rocket Sage, yeah, she's a very prolific Twitch streamer that is a geologist and regularly streams. So if you haven't seen her streams, check them out. Not on Wednesday nights, thankfully. Go Haku. Sorry for this bad joke. What's a geologist's favorite type of music?
rock.
She said dejectedly. You've heard it too many times.
My sister is always like sending me this very cheesy song that I think it was some geology professors put together. That's like some song called Geology Rocks. And she's been sending it to me for 15 years.
Every 3 weeks, she has something on her calendar. It's time to send Emily another email.
The Geology Rocks.
Geology rocks.
She keeps telling me I have to like try to slip it into my like teaching slides, but I can't imagine anything.
Volcano Doc. That's fun. Sorry, they're suggesting a bunch of different streamers that
Oh, okay, cool.
Yeah, there's a healthy contingent of science streamers, and I try to add them so I can, make sure I'm aware of who's out there. That's fun. All right, how's this round going? Or is it over?
I'm upgrading my deck now, so trying to figure out what I want to do.
So this is like level-based gameplay, and you haven't touched for 2 years, and now you're back at high-level playing?
No, I went back to like level 1.
Okay. You didn't try to dive headfirst into that. All right, it's 10:20. We have about 10 minutes before we're going to dive into NARC. If you guys have any questions, now is the time to ask them, particularly while Emily plays Monster Train. Probably get one more round in, right?
Yeah.
All right, let's do another prediction. Which one do you want to do? Do the personal one. That one's another
Yeah.
one. Or one of these.
I feel like that's when this one comes up for me a lot, but I don't know how interesting that is to other people.
That is interesting. All right, we're going to put up another prediction. If you're not following, click the follow button. If you are following, be ready to answer this question. I love the options on this one. So, the question is, holes dug in a typical day of field work as a geologist. We're just going to say average across all of geologists. How many holes are typically dug in a day? Is it less than one or greater than one? Can they do more than one or less than one holes in a given day or a day period of time? Cuttis, welcome to the stream. Thank you for joining us. They requested a factoid, which we'll get back to. But yeah, there's a question. How many holes does a typical geologist dig in one day of field work? Is it less than one or greater than one holes? We do not have a lot of less than one or greater than one questions. This is amazing.
Okay, I'm glad.
I look forward to seeing what the answer distribution ends up on this.
Yeah, I'll be curious.
Cuddle puppy. I mean, footprints are extremely wide, shallow holes.
That's not useful.
Yeah. And then seconder, what counts as a hole, though? I mean, these are fair questions.
Yeah,
we have to qualify. We have rules for minerals definitions. What's the rule for a hole?
I think we have to define a hole as removing dirt in order to access something below the dirt. So I think there's some intent that's relevant.
That's interesting.
Right.
See? Human language, absolutely. What counts as a hole? I did not expect that critique of this question, but here we go.
I should have.
Yeah, no, the intent is a good defining parameter. You have to want to dig the hole for a reason. I mean, you only need one hole. If you need to make more than one hole, I suggest you get another geologist. I'm a mathematician. I'm all about precise definitions. That is fair. Definition of a hole. I did not expect that on my Ask a Scientist Gaming bingo card.
I think it's fair. It's a fair question.
They also didn't say how many dig sites. Yeah,
per day. So it's not about,
All right, Emily, what is the answer? How many holes do you dig?
None.
average?
I almost never dig a hole for any reason, which is like,
Whoa.
it's a surprisingly common question that people ask geologists. Like, how many people think we dig a lot of holes, and I'm not really sure why that is a common idea. I think it's maybe archaeology.
Oh,
Like
yeah,
archaeologists
the
dig lots of
Jurassic
holes.
Park scene and
Right, yeah, and so yeah, paleontologists who are a kind of geologist, they may be digging more than we are, but it's not like I almost never dig a hole. The rocks that I sample are like usually outcrop, so it's places where rock is already sticking out through the dirt where I can see it. Right, if it's under dirt, it's probably like been weathered and it's all messed up by like these surface processes that I'm not interested in. So yeah, I don't know. That's a common.
So you're primarily looking at exposed rock and
Exactly. Yeah. I don't think I've ever dug a hole in my 15 plus years as a geologist.
so the answer is
least-
0.
The answer is 0.
Amazing.
Yeah. How was the spread on that one?
No, it was interesting. It was 3-5, but the people that bet the 3 bet big.
Okay.
So they won a little bit, 1.1 to 1.
Those must be the
payouts.
geologists.
Yeah, so they're like, who's digging? What a waste of time. Oh god, we got a joke from Gohaku. How do geologists ask each other out?
I don't know.
Are you a carbon sample because I would like to date you?
Yeah, that's rough. That's rough.
Not impressed, Gohaku. Good try. No, you're not going to incorporate that into your lectures? All right. I like it. Oof is right, misadventure. Did you Google that one, or did you have that one like in the holster ready for a geologist on stream? You're actually my first geologist on stream.
Oh, really?
Yeah, I've had a few people from EOANS, but not a
Right, but
geologist.
no geo folks.
Yeah. I've had oceanographers on, but yeah. I found the joke on YouTube. Kohaku, thank you. It was worth a laugh. It was worth it.
Yeah, I like a bad geology joke.
Are you carbon because I'd like to date you? Thank you very much. All right, we got 4 minutes before we're going to dive into NARC. If you guys have any last minute questions for Emily, please ask them now. She'd be happy to answer those. Anything related to geology, plate tectonics. Yeah, the factoid about fingernail growth and the spreading of the continents at the same rate. That was That was a really fun one. Speaking of factoid, Cutus21 has requested a factoid. Do you have another knowledge bomb you'd like to drop on the audience?
Oh, okay. Let me think. I had some better ones, but now I'm trying to recall them through the haze of Monster Train.
Part of the fun.
Trying to think. Yeah, I guess here's a factoid. And this will mess up one of the
Yeah, no worries.
questions, but that's fine. The amount of time between us and when Tyrannosaurus Rex went extinct is about 66 million years-ish. And the amount of time between when Stegosaurus went extinct and when Tyrannosaurus went extinct is a little bit more than that. So we're actually closer in time. So I've heard it phrased as like less time passed between T-Rex and the iPhone than the time that passed between Stegosaurus and T-Rex. So when you see those like dinosaurs together in geology kind of art or whatever, it's actually, they were not around, like time is fast, basically.
Yeah. So they're not just wrong, they're like 8 orders of magnitude wrong.
It would be like drawing humans walking around with T-Rex. Like, that's how far off you are.
Oh, Gohaku, not a serious question. Can she name the rock type Pokemon?
Geodude is the main one. I remember. I don't know, like, there's a bunch of... I feel like I always get rock type confused with other things. Geodude Onyx, that's one, the little snaky guy, right? Those are the only ones I can think
I
of.
have no idea. I'm about 5 years too old for Pokemon.
Oh, really?
So you were the Pokemon generation. You had the Game Boy Color and the.
Yeah, we had the Game Boy, like Pokemon Red. I only know like the original 151 Pokemon though. I don't know like all the new ones that are shaped like ice cream cones or.
So belittling of the modern Pokemon universe.
I know.
The original ones weren't that much better. Geodude was rock. Sandshrew is ground. Follow-up. What do you think of the rock and ground being separate types of Pokemon?
I think that's.
As a geologist on record on YouTube.
I will go on record and say it's totally appropriate. I mean, ground is like mostly dirt, which is not a rock.
It's amorphous.
Like dirt often has minerals in it, but like for it to be a rock, it has to be cohesive. So I think ground and rock as separate categories, I'm very comfortable with.
All right, geologist Emily Stewart approves of the partitioning of rock and ground in the Pokemon universe. He rocks. Hey, that's a good question. What is the size necessary to define something as a rock or a mineral?
So mineral, there is no size. I mean, as long as it's big enough to have at least one unit cell of the crystal structure,
Yeah,
it would
it's
count.
crystalline. Yeah. Wait, don't you need more than one?
Maybe you would need two for it to have a repeating pattern.
Yeah.
Yeah, I think that's fair. So as long as it's 2 unit cells.
As defined by Ask a Scientist Gaming tonight, the minimum size is 2 unit cells.
A rock? I don't know if there's an actual technical definition for like the cutoff of a rock. I mean, like, so sedimentary rocks have things we call lithic fragments. So that's like 2 or more minerals stuck together would be like a rock fragment. But is there a size at which you start calling it a rock and stop calling it a lithic fragment? There are all these like size demarcations in sedimentary rock. So there's a technical definition for sand size, fine sand, medium sand, coarse sand. Then you go up to like pebble size things and cobble size things. So I guess, I don't know, I guess I'd say pebble. If something reaches pebble size, according to sedimentary geologists, I'd call that a rock. And if it's smaller than pebble size, then it is a lithic fragment. Unless it's in a consolidated rock. If it's like a pebble within a bigger rock, then the bigger rock is the rock, and the pebble is a clast. I guess. I don't know.
That makes perfect sense. Ecstatic. So can powder of nanoparticles be considered a mineral? Yes, if they're crystalline, naturally occurring, have more than 1 unit cell. That captures it.
I mean, naturally occurring, inorganic. Yeah, so if they're all of those things.
It's a mineral. We'll count it. All right, are you ready for NARC?
I am ready as I'll ever be.
All right, let's do it. We're going to transition to some talking heads while we change screens. Miss Adventure wants to know, what about rock lobsters?
Ooh, I'm a fan.
We approve of rock lobsters as long as they're of a sufficient size. What did you call them?
Pebble?
Yeah, a pebble, and below that is what was the smaller?
Sand, I think.
Yeah.
Is below pebble.
All right, ladies and gentlemen. So for anyone not familiar with the stream, Emily, before you hit start, I'm going to make sure the timer is up. Do you want to see the timer, or do you not want to see the timer?
I feel very negative about this, so I think
No?
keeping the timer away might be. Yeah, we'll see. Just
It's totally up to you. I'll make
no
sure
timer.
Oh, the timer will be there whether you see it or not. So.
Yeah. Just I'd rather be ignorant.
You don't want to know the timer. All right, ladies and gentlemen, for those of you not familiar for Ask a Scientist Gaming, we end every single stream with a game called NARC. It's a bargain bin game for the Nintendo Entertainment System. By bargain bin, I literally mean when Blockbusters existed and you walked out and there was this garbage bin of $5 games. This was one of those games, but one that I had from my childhood. And so I played it once on stream, and the challenge was for others to play it. And so it just became a tradition. But we're going to give you guys a little bit of NARC lore, because here's the NARC cartridge with the backstory on the back. Emily, are you ready for the lore behind what you're getting to?
Yeah.
You are Max Force. Your mission, bust Mr. Big and destroy his dreaded criminal empire. Seize all contraband, stolen money, illegal weapons, use rocket bombs, high-powered machine guns, apprehend all suspects, protect the innocent, and punish the guilty. Stop at nothing. Are you ready for this? I probably should have that memorized at this point, but go ahead and press start whenever you want.
All right.
All right.
It's gotta, I don't know if it's better to like focus or just relax.
Just walk right and go. there's no rules in this. All right, timer is going. You don't have to know what the time is at all, but give it. How's the volume on that? If that's too loud, let me know. Ecstatic, is there a list of guests of the guests of the stream and their times? Yes, I have it on our Discord channel. If you guys join our Discord, I'm sure that info will pop up soon. Let me see, maybe exclamation. I post it occasionally. Yeah, there it is. If you join our Discord, I post it occasionally under, I think, gaming as the subcategory. But yeah, Emily, the goal is go right as fast as you can and find doors. And there's a key card thing.
Oh my god,
that thing. And so yeah, you can kill people. It doesn't save you a lot of time unless they're shooting you. But tapping A is rockets, holding A is bullets, tapping B is squat, tapping B is jump, holding B is squat. Are you a bad enough dude to rescue the president? Heck under. I see you've played bad dudes before. Classic. Yeah, this is NARC, ladies and gentlemen. So I'm always trying to beat it as quickly as possible. Key card, it's realistic. You got to put the key card in there.
Always.
All right. I think I'm caught up on questions. If you guys have any questions, throw them in chat. Ecstatic. Oh, I forgot the naturally occurring. Yeah, that's an interesting metric. I never thought about that as a general.
Secret lab.
I can walk right. They're shooting heroin at you.
Oh my god, they're shooting heroin at me? That seems expensive.
So you didn't grow up in the 80s where they just gave away drugs and shot heroin at you.
What, am I supposed to be going
My
through
childhood
these
was so rough. Emily's in the zone. Yes. Don't talk to Emily unless you want to ruin her time. Ask your questions now. All right. I'll ask one of our other favorites besides the movie one, besides some of the others we regularly ask is... unlimited budget, no moral qualms. What experiment, what study, what would you like to do with an unlimited budget?
The good news is we're already doing it, which is that, like, human-caused global warming is the greatest science experiment of all time.
Oh, jeez.
You know,
we're going dark again.
You want to know, like, what would happen. You know, we want to study ancient...
I'm going to briefly intervene. So you have to shoot these guys wearing black with bullets at close range. So not rockets, but bullets. So hold the shoot button.
Hold.
Yep. So hold, shoot. There you go. Blue card. Right there. All right. That was easy. So now card in. That usually takes way longer. Congratulations. Speed run. All right. So we're doing the experiment of global warming and what the implications of that are.
Yeah. And so, like, if we want to know, one of the big questions is, like, what's the climate sensitivity? Basically, like, if you pump X amount of CO2 into the atmosphere, how much will that warm the Earth? And it was something we never thought we would know. Now look at us. We're finding out in real time. And we spent a lot of money doing it, and it's wildly unethical, so...
Keep going right. No advantage in killing. Just keep going. It's an intriguing experiment. That is for sure, to say the least. Now, Lori Redeemed, take a drink because you're about to drive a car in NARC, so it's time to drink and drive in the NARC universe.
Oh my gosh.
So, cheers, Emily. Cheers, Lori. Thank you for joining us. Tap E to jump in.
Okay, got it.
And stay on the bottom. Cheers. Stay. Explosion, but it saved you some time, so keep going right.
Oh.
No worry, infinite lives, infinite bullets, infinite rockets. You are on a roll.
Excellent.
Coonagis? They're shooting heroin. That seems expensive. Absolutely.
That's what I'm saying.
Thank you for joining us. First time chat in the stream is about NARC and shooting heroin. That is a memorable moment. Thank you for the introduction. But yeah, that was one of the problems with like DARE programs. Did you have to do DARE when you were growing up? It's like they led us to believe that everyone everywhere would be just
drugs all the time.
Giving free drugs.
I know I shouldn't be shooting them. I just
jump over the wall.
Oh, wait, what?
Tap B.
I can
light B. There you go. And go right.
What?
Physics. You're welcome back to the stream. But yeah, it was like, Yeah, everyone was going to be giving us drugs and offering us drugs all the time because that's what they do. They're just malicious. They don't want to make money. They just want to damage
Well, they
society.
get you hooked. They get you hooked on marijuana. Next thing you know, you're.
Yep. No. DeSantis said it's still a gateway drug, despite all the evidence saying otherwise.
Everybody vote next fall.
Oh, man. I'm optimistic about this next cycle. The two constitutional amendments, one for codifying abortion and the other one for recreational marijuana.
Yeah, I think it'll bring people out. I mean, the threshold's pretty high, right? It's like 60% in Florida.
Yep. But I mean, the numbers are pretty close to that. Really depends on turnout of Gen Z.
Yeah. Kids, you're not registered to vote.
Yes, absolutely. I should actually have a hotkey for registering to vote. I'll do a command next time so you guys will get that popping up occasionally. The numbers are really close. When does DeSantis' term end? He's 2 more years, right?
Yeah, because he just ran.
Yeah. You want to get in that car and stay on the bottom of the screen, and it'll take you to the end.
All right.
Actually, you can go up on this one. It'll give you a little bit extra time. Hit a wall, jump over, keep going. I mean, that's the thing about DARE, where it was like, oh, you're going to get free drugs all the time. They minimized real impact of drugs, and they treated all drugs equally.
Right, yeah, which is totally unrealistic.
Yeah.
Right, for people that are struggling with opioid addiction, who were told that smoking pot was just as bad, it's like a real disservice.
Ecstatica. Drugs and AIDS was the scariest thing as a kid, followed by quicksand. I'm going to add Bermuda Triangle to that list. I swear I thought I wasn't going to make it out of high school. Yeah, we talk about this one regularly, especially we had Brian Quaife on. He's in scientific computing, so stay on the bottom of the screen once you get in the car, and it'll take you all the way to the end. He does fluid dynamic simulations, and one of the things he models is fire propagation. And we talked about how in high school, I swear I thought I was going to stop, drop, and roll much more often than I actually do. So yeah, they broke a lot of stuff into our brain. Has Dr. Stewart ever ran into quicksand in the field?
No. I've seen people, you can kind of like try to make your own quicksand by like jumping up and down on the right part of a beach through like liquefaction. But that's not really the same. Oh gosh, or is that a clown?
Clown with a knife.
Oh my god.
1980s. You're lucky you missed it.
Yeah.
I mean, you're free to stop, drop, and roll without being on fire. Good point, Cuddle Puppy. I can use the skills I learned as a child. So you're going to go to the right. You're going to go through this door right here.
I just got killed by a clown.
Simpler times. Emily's focused. You guys got to ask questions. Ask the hard ones. Where's the... Okay, grab that card. You're going to press up through the door, but not too much.
Not too much?
And then go left, yeah.
Oh, I see.
Sometimes people re-enter the door.
Insert the silver safe card, not cafe card.
We'll count it. That's my morning exercise routine, is stop, drop, and roll. I love it. All right, another one of our standard question. What is the Earth is flat / anti-vax equivalent of your field?
Oh, I mean, I think it's Earth is flat.
Literally, Earth is flat. I mean, digging holes was kind of a fun one. I mean, that's not on the same magnitude or scale.
Yeah, I mean, I think
so. You're gonna go left on this one.
The age of the Earth is that's a big one.
Yeah,
I've definitely had. I remember doing.
So you're gonna shoot the Rambo guys with bullets.
Okay.
So that's holding A, and one's gonna drop a green card.
A green card.
Yep.
What would Joe Biden
left.
say? Sorry.
Too soon. So kill that guy, and then the Rambo guy will show up again. Or eventually will. So kill him again, and then bullets when the Rambo guy shows up.
Is the money any good?
So it needs to be at like kind of a close range. So kill the guy in white, confirm, and then you'll maybe kill him. There you go. Up, go left again. Left again. So that's holding. There you go. Green
I got it.
Perfect. Now door. Oh, Huggy Beer redeemed. Take a factoid, and I completely ignored it. All right, Emily, you have a factoid you
How
want to
do
drop?
I pick this up?
Just walk over it.
Oh. Check it out.
Nintendo hitboxes. Sure, it looked like you were up. Huggy Beer, thank you for reminding me. Emily, we got a factoid for Huggy Beer. They spent their valuable internet points on it. What do you want to tell them?
Oh,
We probably
okay.
won't do another prediction, so you could do one of these guys.
Okay. Yeah, I mean, so the oldest mineral that we know of
Go right.
is is a zircon from the Jack Hills in Australia. These are actually like kind of sandstones, basically, but they have little crystals inside of them that are actually older than the age of the sandstones themselves, and they got eroded out of older rocks. And so there's some zircons in there that are 4 point, oh my gosh, are they 4.4, 4.6? They're more than 4 billion years old. Are the oldest minerals that we found on Earth. So we know that Earth was making solid rocks more than 4 billion years ago. It's not that door, is it?
No, you'll keep going to the right. You'll find a door. You'll have all the key cards for these doors, so just keep going right.
Okay.
You'll go through those right away. So 4.4-ish billion years old. For those not familiar, I mean, this is through isotopic labeling that you do these measurements. What do you actually look for in these to age them?
So, zircons are everyone's favorite mineral to date because they incorporate a lot of uranium. So uranium decays over time, and we know the half-life of uranium. So if we can figure out how much uranium has decayed, we can figure out how long it's been decaying. And when it decays, it goes through a whole decay chain. But the kind of last thing that it makes that's actually stable is lead. So we measure uranium and we measure lead in these minerals, and then based on the ratio, we can figure out essentially how long uranium has been in there turning into lead.
That is such a clever measurement. I mean, you need to know about nuclear decay and stuff like that. So who's the first person who was like, hey, uranium can go in these zircon crystals because it's presumably same size of atom. It's relatively similar reactivity.
Yeah, you know, I should know more about this. I know that, like, there is a dude named Claire Patterson who was really instrumental in a lot of this dating, and he later became, like, really big in terms of lead poisoning, right? He was trying to make these very precise measurements of uranium and lead in zircons and other stuff to figure out how old the Earth is. And he noticed,
You can shoot them.
I don't really want to shoot these dogs.
So if you hold both buttons down, shoot and squat, you turn them into puppies.
Oh,
So yeah, they're fine.
that's
they're fine.
Oh, that was...
All right, so
Anyway,
now,
so he was measuring uranium and lead,
so now you're going to kill the guys on screen.
all of them.
Yep. So you're going to shoot these guys with bullets or rockets, and then you're going to shoot that guy in the wheelchair with a rocket.
All right.
So yeah, I have to utter the sentence every stream. Shoot the guy in the wheelchair with a rocket. So tap A. Yep, there you go.
Ooh.
So yeah, he'll come back. You're going to have to do this 3 times. That was close.
Oh, I killed that dog. Oops.
That's
Now I
fine.
can run for vice president.
Too soon.
Sorry, this stream is
topical.
apolitical.
No, exactly. No, we're 18 plus on this stream, so. All right, there you go. Rockets on this adventure. Oh, that's amazing. Oh, there you go. There's
I got
one.
him, I got
So you
him.
got to do it twice
Oh my
more.
gosh, really?
Yep.
Wow, grim.
I mean, he is the drug lord taking him down, so this is.
Oh,
totally
that's fair.
justified.
Yeah. Yeah. He's been terrorizing people and their puppies for far too long. But he realized when he was trying to make these measurements that there was lead everywhere. There's just like a ton of lead around. And he realized that it was because of leaded gasoline, and that leaded gasoline is actually really bad. And the oil companies came and said, hey, if you work on literally anything else, we'll pay you $1 zillion forever. And he declined, and he was instrumental in getting leaded gasoline.
That's amazing. So it was his observations. That was not an intended experiment. It was just like something weird is going on.
Yeah.
Fun factoid for everyone else, the same person that basically came up with CFCs, chlorofluorocarbons for refrigerators, is the one that came up with leaded gasoline.
Oh my god,
Yeah, it's the
seriously?
same dude, and he didn't know. Like, he couldn't have known the consequences. It was the same guy. So, got filthy rich,
Gosh, this
but
guy
obviously...
is too fast. Oh, did he just break into pieces?
No, that's one of the normal guys. They blow up.
Okay, I see.
That man is a menace, but he didn't know. He was really genuinely trying to do good science. They worked. They did what they were supposed to do, but he couldn't have known the consequences of it floating into the atmosphere or getting into the, like, streams and aquifers
This
and
wheelchair
whatnot.
guy is turning out to be a lot harder than... She's just so really fast, and I feel like I'm not... My rocket's not fast. I guess I have to, like, lead the target.
Yeah, a little bit. And one thing I recommend, don't push the button really hard. Just kind of tap it lightly.
Yeah.
The harder you press, the more time it spends.
Right.
Yeah. He knew the consequences of leaded gasoline. He repeatedly had to go on medical leave for lead poisoning while overseeing the process. So he had real-time information on his own experience with leaded gasoline. Yeah, it's the Nobel Prize all over again. No, that's true. Alfred Nobel did not... I mean, I guess he knew it was explosives, but yeah. Forever chemicals is another one. Yeah, that and microplastics are... We're learning a lot about various different things. So kill the guys. Yeah, there we go.
He's back, but I just don't... He's too fast.
Yeah, it's easier if you're in the middle, because then you have a chance of getting him on the up and down.
Okay.
Speaking of health-related things, Gohaku has a question. How does charcoal work in purifying water?
I don't know.
That is interesting. I
guess I assume it's like an absorption thing, but I like that something about it like is that it's like a reactive surface. It's like pulling things onto it, but I don't know actually. Do you
Yeah, I
know?
think it's very high surface area, but it's slightly hydrophobic, so it'll pull out any like oils and stuff like that. It's a Telepis Sleepy. It's maybe my favorite question of the night. What is your favorite carcinogen?
Oh, asbestos.
I love that Emily had an answer immediately available for that.
There's some amphibole minerals are asbestiform, and that was one of the first minerals I really studied closely.
Yeah,
So, yeah.
asbestos.
Although, like, you know, silica, right, I think can be carcinogenic. I really just...
Okay, you got two, so one more. So yeah, kill the guys on screen. He'll come back at some point. What's your favorite carcinogen? And Cuddle Puppy said social media. That's fair. Are you on social media?
Right,
Are you
Fox
Facebook,
News?
Twittering?
Not really. I mean, I have, like, a secret Facebook that I don't tell my colleagues about. But
For
I
the
don't...
best.
Oh, I got it.
That's to keep up with family and whatnot.
Yeah, and, like, old friends and stuff. Okay, I got the card.
All right, now door.
It took a minute.
A little bit of time.
All right, I need to put the card in
Yep.
first.
Oh, this is a realistic game. Ecstatic has a follow-up. What are your thoughts on earthbending in Avatar? How come did the earthbenders were able to bend charcoal, which is just wood? Oh man.
Yeah, I mean, yeah.
So top of the screen,
All right, this is
you're
the
gonna
guy
have to
with...
jump.
Okay.
Yep, jump rocket. So in the air and tap A on the way down. So get away from him. Let's go far to the right. You're gonna do it over and over again. We obey the laws of physics in my house. Absolutely, misadventure. Have you seen Avatar? Or you?
Oh yeah, I've seen the whole series. I taught my dog to jump when I say yip yip. So...
So how do you feel about earthbending able to control charcoal? Oh, that was close.
Yeah.
Is it a mineral? That's a good question.
Charcoal, not a mineral because it's not inorganic.
Oh. Yeah, it's just burnt wood. So yeah, that doesn't make sense that the earthbender can control that.
Yeah, I mean, I think any geologist... Oops, I need to do this.
Ooh, that was very close. Saw it went right over the head.
Yeah, I saw. Get away from me, Mr. Big.
So I'd recommend tapping the button lighter.
Okay, that's the key.
I love that we explored the geology of both Avatar and Pokemon tonight. Is there any other Gem in the Holograms? That one came up, at least for the nomenclature. She's doing pretty well. Yeah, Miss Adventure, she's gonna get this. It's a matter of time.
I don't need your pity.
She did solve the Sunday New York Times crossword in 15 minutes and 15 seconds.
Oh.
I think she could take on Mr. Big.
Man, it's really... I haven't gotten any hits, have I?
Did she beat the speedrun record? No. So the world record is 9 minutes and 4 seconds. The record for an Ask a Scientist guest other than me is 17 minutes and 53 seconds or something like that. I feel like Mr. Big can stall your guests for 20 plus minutes. Yeah, that's fair. Well, what sucks, my brother actually... Oh, there it is. Okay, now just in the face. All right, now what you're going to do is walk away from him, and you're going to stay between these black lines here, and you're going to turn...
And these ones?
Yep. So you see those two black lines? You're going to turn back and shoot bullets. So you just have to hold A, but move up and down while holding A. And you saw that vertebrae go away? Yep, just like that. You're going to keep doing that, and you're going to get the rest of it. That's the hardest part. Now you're on to... It's arguably easier, but still annoying, because Nintendo hitbox doesn't make sense. Cuddle Puppy wants to know what the second place record is. The answer is me at 9 minutes and 7 seconds. All right, keep going. Card door. That's perfect. So Emily, Cuddle Puppy wants me to tell you that I'm the former world record holder.
Oh,
in speedrunning
I know.
Right.
I know. You think I would go on anybody's Twitch stream?
If it wasn't. But this is why I make guest plays, because of people like Cuddle Puppy. Yes, I am famous, Cuddle Puppy. Thank you very much. 21 minutes and 55 seconds. I want to say that puts you in the top 15 of guests. Ooh. I'll have to look at the exact numbers, but that is it. That's on your business card. No, I'm working on my full professor package right now.
Yeah, you put that in your...
It's on my CV. Former world record holder.
If you get the world record holder to write you a letter, yeah.
He should. So what happened was there was a previous record at 9 minutes and 28 seconds. Then someone like Cuddle Puppy challenged me on stream to beat the record. So I studied the shit out of this game till I found a glitch on the Mr. Big wheelchair, where if you despawn him off the right side of the screen, he comes back right away.
Oh,
and that saved me 20 seconds, and I got the 9 minute and 7 second record, and then I told the previous winner about it, and then he stole the record back. So yeah, he owes me a letter recommendation for full professor. But anyway, ladies and gentlemen, we come to the end of the night. If you guys have suggestions on people we should rate, preferably science-related streamers, because they're always related to stuff we do. If you guys have suggestions on science-related streamers, other suggestions as well, we'd be happy to take them. But yeah, that's the stream for the night. We've been on a heck of a journey, including several interventions with Stalin and what else do we do? CO2, and man, it was definitely a journey. But Emily, it's been a pleasure having you on stream. Thank you for joining me. Emily and I actually met at the in-person Ask a Scientist in, what was that, May?
Yeah.
And so I was like, hey, do you want to do this stream? And she's like, yes, I do. So thank you for joining me. Any parting words for the audience?
Oh yeah, thanks for hanging out, and don't buy natural diamonds.
Also known as blood diamonds, because yeah, terrible industry. But no, thank you for joining us. We learned a lot. We learned about minerals the size of rocks. We learned about plate tectonics. Thanks, Dr. Stewart. Chat likes your sense of humor. Go Haku. Thank you for the comments. Thank you all for joining us. Your questions take us on an amazing journey every single night. Emily, hopefully you had some fun revisiting some old games, and you
breccia.
Full circle. Thank you, Go Haku. And congratulations, you won the war on drugs. If nothing else tonight, you have achieved that.
Yeah.
So congratulations on that. Closing comments. In terms of next guest, I don't know who it's going to be. My goal is to have somebody on June 19th, which is 2 weeks from now on Wednesday night. During the summer, it's a little bit hard to schedule people, so I'm still working on solidifying the schedule for the summer. At the worst case scenario, I will be the guest and I'll find somebody to host the stream so you guys can learn about photochemistry and photophysics. But I'll do my best to get a different guest on the stream, so you guys, I'll keep you posted. Summer plans, I will have a schedule. I am going to have somebody almost every 2 weeks. I just got to solidify one more on June 19th, and then I'm set through August with the rest of the stream. So I'll get one more. I'll post it on Twitch. If you guys aren't joining us on the Discord, make sure to check out the Discord. Join us on there because the schedule's there, plus the bio for new guests is there as well. So but anyway, thank you all for joining me. Emily, thank you for joining me on stream. Hopefully I had a good time. But yeah, we'll figure out who the guest is going to be in a couple weeks. Until then, stick around. We're going to raid somebody, hopefully a science related streamer. But until next time.